Hello everyone, welcome to my channel Genetics. If you want to master Matplotlib from scratch and learn how to create professional data visualization in Python, this video is for you. In this complete Matplotlib tutorial, we are going to cover everything from beginner to advanced level, step by step. We will start with prerequisite, where I will quickly cover the basic prerequisite including Python fundamentals, NumPy and Pandas that you need before learning Matplotlib. Then in module 0, we will understand data visualization basics, why visualization is important and where Matplotlib fits in real-world data analysis. In module 1, we will set up our Matplotlib and create our very first plot so you can understand the basic plotting workflow. In module 2, we will cover one of the most important concepts in Matplotlib, figure, axis and axis. So you can understand how Matplotlib actually works behind the screen. After that, in module 3, we'll run chart customization technique like titles, labels, legend, grids, theme, and styling so your visualization looks clean and professional. Then in module 4, we'll run line plots and understand how to visualize trend effectively. In module 5, we'll move to the bar chart where you will learn how to compare different categories of data. In module 6, we will cover scatter plot and understand how to analyze relationship between variables. Then in module 7, we'll learn histogram and understand data distribution concept like bins and frequency. In module 8, we'll cover pie charts and learn how to visualize part to whole relationship properly. In module 9, we'll learn annotation and text in Matplotlib, where you will understand how to highlight important points in your chart using text, arrows, maximum and minimum values, annotations, and make your visualization more insightful and storytelling focused. And finally, in module 10, we will explore advanced plot types like box plots, violin plots, area plots, stack plots, error bar plots, stem plots, and stack plots so you can handle more advanced real-world visualization use cases with confidence. So by the end of this video, you will have a strong understanding of Matplotlib fundamentals and you will be able to create professional charts confidently for data analysis, machine learning project, dashboard, and real-world applications. So without wasting any time, let's get started. First of all, let's understand what are the prerequisite in order to learn about Matplotlib. Okay, Matplotlib, right? So first thing is Python. Okay, in Python you have to cover variables and data types. Okay, string and conditional statement. Okay, you have to cover list, tuple, dictionary, sets, right? You have to cover loops, you have to cover function, and you have to cover object oriented programming. It is recommended. Okay, it is optional. In order to understand your Matplotlib, OPS is optional. Okay, but it is recommended. Okay, now next module is that you need to run, that is NumPy, right? The second prerequisite is NumPy. NumPy is basically a Python library that is used working with arrays. Okay, working with arrays. Okay, and numerical computations. Okay, in NumPy, basically you have to cover how to create arrays. Okay, then you have to cover types of arrays, okay, like 1D, 2D, okay, multi-dimensional, okay, different type of dimensional arrays, okay. Next, you have to cover indexing and slicing. Then you have to cover operation, basically mathematical operation, okay, operation on arrays, okay, and some inbuilt function like mean, that is average, max, mean, sum, like this, okay. These are the things that you need to cover in NumPy, okay. Next module that is a prerequisite, that is pandas, okay. Pandas is used for data analysis, cleaning, and manipulation, okay. So in pandas, basically you have to cover like series, okay, data frame, then you have to cover few basic operation like dot head, okay, dot tail, dot shape, and many more, okay. Then you have to cover how to read data, okay, different type of the files, that is it may be CSV, Excel, SQL, HTML, JSON, like this, okay. So these are the things that you need to cover in pandas, okay. So these three are the prerequisite for in order to start your Matplotlib journey, okay. Python, NumPy, and pandas, right. See guys, I have already created dedicated video on Python, NumPy, and pandas, okay. Complete video I have already created on my channel. If you not yet watch this video, please go to my channel and watch these videos, because these are the prerequisite and these are the best in order to start your data science journey as well as Matplotlib journey. So I recommend you just go to my channel and watch this video before starting your Matplotlib journey, okay. Now we will understand what is data visualization and Matplotlib, okay, right. So what is data visualization? Data visualization basically represent data using chart graphs, okay, using chart or graphs, okay, instead of raw data, okay. Suppose you have a data like this: person and sales, okay, A, B, C, and D, okay. Now A person is having 120 cells, B person having 150 cells, C is having 170, and D is having 200, okay. Now if I ask you who is the highest seller, you can say that is D, okay, because this is 200. And who is the lowest seller? That is A, right? Because you have only 4 data, so it is very easy to understand, right? But suppose let's say you have millions of data, okay. Now is this possible to find out from millions of data who is the highest seller and who is the lowest seller? No, right? So in that case, what we can do, we can represent our data graphically, okay. Suppose this is 0 and this is 500, okay. Now A, B, C, D, okay. Now the value of A is 120, somewhere suppose here, okay. the value of B 150, somewhere here, C 170, somewhere here, and D 200. Okay, somewhere here. Okay, now in this way, if you plot millions of data, now it is very easy to understand which is the highest point, right? Which is the highest point and which is the lowest point, right? So in the same way, if you represent your millions, thousands of data or millions of data, if you represent this data graphically, then it is visually it is possible to understand, or it is possible to mark which is the highest point and which is the lowest point, right? You can easily point it out, right? So this is the advantage of data visualization. Okay, so data visualization is the graphical representation. Just remember that data visualization is a graphical representation of data using charts, graphs, or maps to make information easier to understand. Okay, so this visualization help us to find out trends. Okay, to find out trends on our data. We can find out the outliers. Okay, outliers in our data. We can compare our different type of data. Okay, so these are the reason we need to use data visualization. Okay, now if you think what is the real life example where we basically use our data visualization, then you can consider like sales growth. Okay, sales growth in any e-commerce platform. Okay, sales growth. You can even see stock price trend. Okay, stock price trend. You can see patient in hospitals, basically patients data trend. Okay, so these are the real life use case where we need to use data visualization. Okay, now types of visualization. Okay, types of visualization. So we have line chart. Okay, line chart basically used trend to find out trend over time. Okay, second we have bar chart. Basically bar chart used for categorical comparison. Okay, next we have scatter plot. That is basically relationship between variables. Okay, to establish a relationship between variables, we need to use scatter plot. Okay, next we have histogram. Okay, so using histogram we can see the distribution of data. Okay, using histogram we can see the distribution of data, how our data is distributed. Okay, another is pie chart. So basically pie chart we use to find out the percentage distribution. Okay, so these are the basic visual that we need to use in data visualization. Okay, and one more thing that is very important, always remember which chart should be used when. Okay, for example, if you need to find out the trend, then you have to use line chart. If you want to find out any comparison, then you have to use bar chart. Okay, you have to when you want to establish any type of relationship, then you have to use scatter plot. Okay, for distribution of data, histogram, pie chart, like this. Okay, so always remember which chart should be used when. Okay, next is Matplotlib. Okay, Matplotlib. So Matplotlib is a Python library used to create visualization. Okay, so these are the visuals. Okay, these are the visuals. So basically, this visualization we need to use. You need to create for data visualization. So what is Matplotlib? Using Matplotlib, we basically create this type of visuals. Okay. So Matplotlib is a library for creating static, animated, and interactive. Okay, interactive visuals. Okay. So in Matplotlib, we can create static, animated, and interactive visuals in Python. Okay. So what are the importance? Okay, what are the importance of Matplotlib? Okay, see, one is it basically works with NumPy and Pandas. Okay, it is highly customizable. Okay, it is highly customizable. It is industry standard. Okay, it is industry standard, and it is used in data science. Okay, data analyst, business analytics. Okay, machine learning, everywhere. Okay, so these are the importance of Matplotlib. So if you consider any kind of data flow in data science or data analytics, then how visualization fits in this data flow. Okay, suppose this is a data flow. Okay, this is a data flow. The first thing is we need to collect our data, right? Then we have to clean our data, basically using pandas. Okay, then we have to analyze our data. Okay, after analyzing, we have to visualize our data. Okay, here we can use Matplotlib. Okay, and once our visualization is ready, then we can make our decision. Okay, so this is basically the data workflow for any kind of data in data analysis or data science field, right? So here, this is how basically we work. First of all, we collect our data, then we clean our data, then we analyze our data, then we visualize data using Matplotlib, or there are many different type of libraries there in Python. Okay, and finally we make our decision, right? So I hope you understand what is data visualization and what is Matplotlib. Okay. So before starting our practical journey, let me create my repository. Okay, Matplotlib tutorial. Okay, this public and readme file, Python, and license is MIT. Okay, so I'm creating my repository. So my repository gets created. Now let me copy the URL. So this is my local folder where I'm going to clone my repository. Okay. So in order to clone my repository, I have to write git clone, and I have to paste my URL. Okay. Now it's cloning. Okay. Now see, my repository gets cloned. Okay. So my repository gets cloned in my local system. Now I have to open my editor. Okay, code editor. So I'm opening my VS Code editor. Okay, fine. So before starting any coding, it is always recommended to create your own virtual environment, right? So I'm creating my virtual environment. So I'm opening my command prompt. Now I have to write py. Basically, I want to use my Python version of 3.13. Okay, so I have to write pi space minus 3.13 minus m venv space my env. So this is my virtual environment name. Okay, so you can give any kind of name over here. Okay, and pi minus 3.13 because different type of Python, multiple Python version is installed in my system. So I want to use specifically this version. So I have to write like this. Okay, pi space minus 3.13 minus m venv. Then I have to provide my virtual environment name. Okay. Now if I press enter, now it is creating my environment. Now see, my env folder gets created. That means my virtual environment has been created. Okay. Now I have to activate my virtual environment, right? So for that, I have to write my env slash script slash activate. Okay. Sorry, activate. Okay. Now see, my environment gets activated. Okay. Now I have to start my work. Okay. Now, first of all, I'm creating my first folder, that is module 1. Okay. Now here I'm creating my new file, first plot.ipynb. Okay. I'm using my Jupyter notebook. Okay. So I'm using .ipynb extension. Okay. But before that, I have to install Matplotlib in my virtual environment, right? So for that, I have to write pip install Matplotlib. Okay, Matplotlib, and press enter. Now Matplotlib is getting installed in my virtual environment. Okay, so it is collecting all the package and installing in my virtual environment, right? So now Matplotlib gets installed in my virtual environment, and now I can start my work. Okay. Now, first of all, I have to select my kernel, and I have to select my virtual environment. That is this one. This one, right? Okay. Now let me check my Matplotlib has been installed or not. Okay. So for that, I have to write import Matplotlib. Okay, and print Matplotlib dot underscore version. Okay, version underscore. Now if I execute, now it will install another package, that is IPY kernel. Okay, let me install first. So my IPY kernel gets installed successfully, and my this shell gets executed automatically. Okay, and it is giving me output as 3.10.9. Okay, that means this is my Matplotlib version. Okay, so my Matplotlib is successfully installed in my system. Okay, so to start our coding, first of all, you have to import our Matplotlib. Import Matplotlib dot pplot. Okay, see, pplot is the main module used for plotting. Okay, so basically we create our different type of graphs, so you have to plot our graphs, right? So for plotting, we have to use this pplot module from Matplotlib. Okay, this is the main module that we need to use for plotting. Okay, so always you have to use import matplotlib.pplot as plt. Okay, plt is allies, nothing else. Okay, this is the allies. So whenever you need to use this module matplotlib.pplot, just write plt. That's it. Okay, that is why we need to use this allies. Okay, so we have successfully imported our pplot. Okay, now I'm creating two values. Okay, one is x. Okay, and creating one list 1, 2, 3, 4. Okay, another value of y, that is 10, 20, 30, or 25, 30. Okay, so basically x is our x-axis value. Okay, we'll create our graph, and each graph is having two axes, that is x and y. So this is my x-axis value and this is my y-axis value. Okay, now to plot these two values, x and y, you have to write plt.plot. Okay, this is the comment plt.plot, and here I have to pass my two values, that's x and y. That means we are plotting our x value and y value. Okay, we are plotting our x value and y value, and this is my x axis and this is my y axis. Okay, and in order to show this graph, we have to write plt.show. Okay, if you don't pass plt.show, then you will not get your graph in as a output. Okay, always you have to write plt.show at last. Okay, now if I execute, now see, this is my graph. Okay, this is my graph. This is the x-axis, this is my y-axis. Okay, in x-axis I have 1 to 4, so 1, 1 to 4, right? And in y-axis I have 10 to 30, so this is my 10 to 30, and these all are my point. Okay, 1, 2, this is my 1 and 10, this is my 2 and 20, this is my 3, somewhere around 325, and this is 430. Okay, so we have created our first plot successfully. Okay, now one more thing, suppose you don't pass x. Okay, if you don't pass x, and if you write just y and plot plt.plot y, then also it will get executed. Now see, why? Because whenever you pass a single value, then x automatically gets created, and it will start from 0 to 1, 0 onwards. Okay, so whenever you pass any single value, the second axis value automatically gets created, and the value will start from 0 onwards. Okay, 0, 1, 2, 3, 4, like this, right? So we have created our first plot, and how to customize this type of plots. Okay, I'll show everything one by one in my coming slides. Okay, don't worry. Next, we will understand about figure versus axis versus axis. Okay, what is the difference between figure, axis, and axis, right? So figure is basically the whole canvas. Okay, now whenever you execute your code and you get your output, you get your graph as output, then the entire screen is called figure. Okay, this entire canvas is called figure. The figure is the entire window. Okay, entire window or page that holds all the plots element. Okay, this is the entire screen. Here we will create all our plots. So this entire canvas is called figure. Okay, this is called figure. Understand? This entire figure holds all the plots that you will create. All the plots will be holding by this figure. Okay, next is axis. Axis is the main interface. Okay, the main interface for plotting data and customizable plot. Okay, customizing our plot. Suppose, for example, this is your entire screen. Okay, this is the entire canvas. So here you want to create 4 figure. Okay, now for that you have to split your entire screen like this, right? 2 column, 2 rows. Now here I am creating my one plot 1. Okay, here I am creating my plot 2, here I am creating my plot 3, here I am creating my plot 4. Okay, this 3 plot I am creating within my entire figure. Okay, so this each space is called axis. Okay, this each space is called axis. So the entire screen is my figure, and within this figure, how many space I am creating, that is called axis. Okay, and next is axis. Okay, axis. Now here I am creating my, suppose here I am creating my line chart. Okay, here I am creating my bar chart, whatever it is. Okay, here I am creating my scatter plot, here I am creating my pie chart. Okay, so any chart, any graph I am creating in each space, all the graph is having its x-axis and y-axis, right? It is also having x-axis, y-axis. It is also having its x-axis, y-axis. It is also having its individual x-axis, y-axis. Okay, so this is axis, this x-axis, y-axis. This is called axis. Okay, so this is my entire. This is so this entire plot is my figure. This entire plot is my figure. This within this figure, this each space is axis, and each axis, whatever plot I am creating, each plot is having its own axis, x-axis and y-axis. That is called axis. Okay, so I hope you understand what is figure, axis and axis, and what is the difference between them, right? Now to understand how to create axis and how to plot your graphs in each axis, you have to understand two things. Okay, before that you have to understand two things. That is, one is subplot, okay, and another is subplots. Okay, subplots. One is subplot and another is subplots. Okay, yeah. Subplots. Subplot is a singular. Okay, always remember it is a singular. So it creates one plot at a time. One plot. Okay, it creates one plot at a time. For example, suppose this is my entire canvas, that is my figure. Okay, and within this figure I want to create 4 axes. Okay, that means I want to create my 4 plot. Okay, so this is my axis 1, this is my axis 2, this is my axis 3, and this is my axis 4. Okay, now I want to create this type of structure using subplot. Okay, using subplot. So is the syntax of for subplot, that is plt dot subplot, and here I have to pass my number of rows, comma, number of columns, okay, and index, and always index starting from 1. Always remember this index starting from 1. Okay, so what is the index? This axis is my index. Okay, this is my index. This is index 1. This is index 2. This is index 3, and this is index 4. Always remember the indexing start from left to right and top to bottom. Okay, so left to right, so this is 1, this is 2, and top to bottom, so this is 3 and this is 4. Okay, so in order to create this type of structure, we have to write plt dot subplot. Okay, now here I have to pass how many rows and how many columns. So I have 2 rows, 2 columns, so I have to pass 2 rows, comma 2 columns, and here I have to provide index. That means in which axis I want to create my graph. Okay, for example, if I want to access this one, then I have to pass 1. Okay, then you have to pass your plt dot plot and you have to pass your x and y for this axis, okay. Now in this axis you want to create another graph, so for that you have to write plt dot subplot. Then how many rows we have? 2. How many columns we have? 2. And in which index I am to create my graph? That is index 2. That means I have to provide 2. And here again I have to write plt dot plot, and I have to pass my x and y. Okay. So in the same way, if I want to access this axis, then I have to provide 2, 2, 3. And here I have to write 2, 2, 4. This is my index 4. This is my 2, 2, 1. This is my 2, 2, 2. Right? So this is how manually you have to create all the axes one by one, and you have to put your index, and then you have to plot your x and y. Okay. So what is the limitation for this subplot? Okay, limitation. Okay, limitation is it is not flexible. Okay, that means whenever you write something like this 2, 2, 1, 2, 2, 2, then only this axis gets created. Once you write 2, 2, 1, then this axis gets created. Once you write 2, 2, 2, then only this axis gets created. Okay, so one by one we have to create our all axes, right? So this is not flexible. Second one is it is hard to manage for large layout. Whenever you create your multiple chart in your entire canvas, then it is very difficult to manage the entire layout size. Okay, you cannot control this entire layout size. Okay, and third one is you don't have any direct access of this object of this axis. Okay, you don't have any direct access of all the object of each axis. Okay, this is the limitation for subplots. Okay, subplot. Now that is why subplots comes into the picture. Okay, so subplot is a plural. Okay, it creates entire grid at once and gives you access all the plots. Now, for example, if you create 2 of 2, this type of plot, then all the axes gets created at once. Okay, all the axes gets created at once, and you have the access to for each axis. Okay, so what is the syntax for these subplots? That is, you have to write something like this: figure, comma, axis equal to plt dot subplots, and here you have to plus number of rows and number of columns. That's it. So this figure is my entire canvas. Okay, this axis is my plots. Okay, this axis is my plots, and this plt dot subplots creates all the entire figure and all the axes. And here I have to pass how many columns and how many rows I want to put in my canvas. Okay, now you have the entire control on plots and canvas. Okay, now for example, if you want to create single post plot, okay, single plot, okay, then just write figure axis equal to plt dot subplots, and you don't need to pass anything in this parenthesis. Then it will create a single plot. Okay, it will create a single plot. Now, for example, you want to create something like this: one row, 3 colors. Okay, for that you have to write figure axis and plt dot subplots, and here you have to press 1 row, 3 column. Okay, 1 row, 3 column. Then in order to access each axis, okay, in order to access each axis, you have to write something like this. Always remember, this is our axis starting from 0. Okay, our axis starting from 0. Now, in order to access this axis, we have to write ax, okay, ax of 0. Okay, that means this position. Now, in order to access this one, this is my 1, this is my 2. Always starting from 0. Okay, 0, 1, 2. Now, in order to access this position, we have to write ax 1, and in order to access this position, we have to write ax of 2. Right? Because this is 1D. This is 1D. Always remember, this is 1D. Okay? In the same way, if we need to create three rows, okay, 3 rows and 1 column, okay, then we have to write something like this: figure access, same thing, plt dot subplots, and here I have to pass how many rows I have, that is 3, and how many columns I have, that is 1. This is also 1D. Okay, this is also 1D. Then in order to access this point, this is 0, starting from 0, 1, 2. So in order to access this position, I have to write ax of 0. For this position, we have to write ax of 1. And for this position, that is this position, I have to write ax of 2. Okay. And one more thing, whenever you create your access and you using access, you are accessing your position, then you don't have to write something like this plt dot plot. You cannot use plt dot plot. Okay, you have to use something like this: ax of 0 dot plot. Here you have to pass your x and y. Here also plot x and y, plot x and y. Here also you have to write x of plot. Okay, this is how you have to plot your. Whenever you are not using your access, then you can plot your graph using plt.plot. But whenever you are using access, then you have to plot your graph like this. Okay, access.plot. This is the syntax. Okay, access.plot. Okay. Now this is my 1D. Now suppose I need to create 2D. Okay, for 2D array. Suppose I want to create 2 by 2. Okay, this is my 2D, 2 by 2. Okay, this is my structure. Okay, now in order to create this structure, we have to write figure access equal to plt dot subplots. How many rows I have? 2. How many columns I have? 2. Right? Now, in order to access this axis, what you have to write? As this is my 2D array. Okay, this is my 2D array. So we cannot write ax of 0, ax, ax of 1, ax of 2 like this. Okay, that is for 1D. This is for 1D. Okay, but in case of 2D, you have to write row and column both. Okay, so always remember this is also 0, 1. This is also 0, 1. Okay, so what is the position for this axis? That is 0, 0. This is my 0, 1. This is my 1, 0. Okay, and this is my 1, 1. Okay, so for that I have to write something like this: ax for this position. For this position, I have to write ax 0, 0. Then I have to plot my graph. Plot x comma y. Okay. In order to plot my graph in this axis, I have to write ax 0, 1, right? Dot plot. Then I have to pass my x and y. In the same way, to access this position, I have to write ax 1, 0, right? Dot plot, and I have to pass my x, y. Okay, and in the same way, in order to access this position, I have to write ax 1, 1 dot plot, and I have to pass my two values, that is x and y. right? So this is how you can create your axis at once using subplots, and you can plot your all graphs in each axis, and you have the complete axis on object of each axis. Okay. Now there is another way. Whenever you using 2D array, then you have to pass something like this, row and column. But there is another way to execute this code by converting this 2D array into 1D array. Okay. So for that, just you have to write ax equal to ax dot flatten. Okay. If you have seen my NumPy close, then you must be knowing about flatten. I have shown everything. What is flatten? Flatten basically converts my 2D array to 1D array. Okay. So if I convert this my 2D array into 1D array using flatten, then instead of writing ax 00, ax 01, 1011, you can write something like this: ax of 0 dot plot ax of 1 dot plot ax of 2 and ax of 3, something like this. Okay, this is my 0, this is my 1, this is my 2, this is my 3. Okay, so this is how you can also execute your code by converting your 2D array into 1D array. Okay, I'll show everything in practical. So I'm creating new folder. Okay, module 2. Okay, now I'm creating another file, that is access dot ipyl. Okay, so I'm selecting my kernel. Okay, now first is, let's start with subplot. Okay, subplot. Now in subplot, let's create 2 by 2. Okay, 2 by 2 matrix. Okay, 2 by 2. That means I need to have 2 rows and 2 columns. Okay, now for that, in order to create this type of structure, first of all I have to import my Matplotlib. So import Matplotlib dot pplot as plt. Right, now I have to, first of all I have to define my axis, which axis I am to create. First of all, I want to create my axis of index position 1. Okay, for that I have to write plt dot subplot, and here I have to pass my row, number of columns, and index. Okay, so my row is 2, column is 2, and I want to create my plot in my index position 1. Okay, now I have to plot my all the values, that is x and y. Okay, so for that I have to write plt dot plot, and here I have to pass my x and y. Okay, so I am putting my x value as 1, 2, 3. I am just passing my values directly. Okay, and as the y value I am passing 4, 5, 6. Right, in the same way, as this is my 2 cross 2 matrix, so I have 4 plots. Right, so I have to create 4 axes. So in the same way, I have to create 4 axes. Right, so this is the index position of 1. So 2 column, 2 row, 2 column, and this is the index position of 1. Now this would be index position of 2. Right, this would be index position of 3, and this is the index position of 4. Right, now let me change all the values. Let me keep 1, 2, 3, and this is 6, 6, 5, 4. Okay, keep it 1, 2, 3, and 2, 3, 4. 2, 3, and 4, 1, 2, 3, and 9, 8, 7, whatever it is. Okay, 9, 8, 7. Right? So my axis is created. Now I have to, in order to show all the plots, I have to write plt.show. Right? Always remember you have to pass this plt.show, else your plot will not be created. Okay. So now if I execute, now see, this is my 4 plot. This one is my, see, these 2 row 2 column, right? 2 row 2 column. This is my index position of 1. This is 2. This is 3, and this is the 4. Okay. So this is how we can create our all the plot. We can plot all our graphs using subplot. Okay. But as I told you, there is some limitation. This is not flexible. Okay. This is not flexible because whenever I pass 2 to 1, then only this axis gets created. When I pass 2 to 2, then only this axis gets created. All the axis is not gets created at once. Okay. So this is the manual work. And when this, the entire frame, the entire figure, okay, you cannot manage the entire figure size. Okay. If your program is bigger, then you have to manually put all the plot one by one, and for that you cannot manage your entire canvas size. Okay, this is the most disadvantage. Okay, and the third one is you cannot access the axis object. You cannot this object for of each axis. Okay, in that case, to overcome this type of issues, subplots comes into the picture. Okay, subplots. Next is subplots. Okay, subplots. So in case of subplots, what happened? Subplots is plural, as I told you. Okay, let me write plural. Okay, that is why whenever we use subplots, it creates all the axes at a time. Okay, because it is plural, and as subplot is singular. Okay, it's create at a time one plot. Okay, that is why when we pass this one, it creates only this axis. Okay, it creates one by one because it is singular, and subplots is plural, so it creates all the axes at once. Okay, so if we create all the axes at a time, okay, if you want to create all the axes at a time using subplots, then the syntax is figure, okay, then ax, then you have to write plt dot subplot. Okay, this is the syntax. Okay, now first of all, let me start with one row and 3 column. Okay, that is basically 1D array. Okay, 1D array. Now for that, first of all, we have to import our Matplotlib. So import Matplotlib dot pplot as plt. Okay. Now as I have 1 row and 3 column, so I have to pass, the syntax is within this parenthesis I have to pass my number of rows and number of columns. Right, this is my syntax. So what is the how many rows I have? That is 1. Okay, and how many columns I have? That is 3. So I have to pass like this. Okay, as this is my 1D array. Okay, so in order to 1D array, whenever we want to access my axis, then you have to write ax of 0, and always remember it is starting from 0. Okay, so this is my first axis. Now how many axes we have? 3, 1 row 3 column, that means 3 into 1, that means 3. We have 3 axes, right? So this would be my second axis. Okay, and this would be my third axis, right? As this is my 1D array, so I have to write like something like this: 0, 1, 2. Always it starts from 0. Always remember. Okay, so we have to access to access the first axis, we have to write ax of 0. In order to access the second axis, we create ax of 1 and then ax of 2. Okay. Now, as we are plotting our graphs using axis, okay, using axis, so we will not use plt.plot. Okay, we will not this plt.plot. Instead of that, we use this axis dot plot. Okay, and within this, we have to pass my x and y. So let's suppose I am taking this example. Okay, in the same way, here I have to pass my another value. Suppose this one. Okay, and here again I have to write plot, and then I have to pass my third value. Let's suppose this one. Right? So I have access all my axes, and in each axis I have plotted my all values. Okay. Now in order to get my output, I have to write plt.show. It is common, right? Now if I execute my code, subplot. Oh, sorry. This should be subplots. Okay. Now if I execute, now see. You can understand I have only one row and I have 3 columns. Okay. 1 row and 3 columns. And this is my first axis, that is ax of 0. This is my second axis, that is ax of 1. And this is my third axis, that is ax of 2. Okay. So this is my 1D array. Okay. This is my 1D array. And this is my 3 axis. Now in the same way, let me create 3 row, 1 column. Okay. These also 1D. These are also 1D array. Now I'm taking the same example. I'm taking same example. Here also, first axis is 0, second is 1, third is 0, third is 2, right? Now if I, here I have to change how many row I have, that is 3, and how many column I have, that is 1. Okay, and rest are same. Now if I execute, now see, this is my 1 row, 3 column, right? And here I have 3 row, 1, 1, 2, and 3, 3 row, and I have only 1 column, right? This is my axis 0, this is my axis 1, this is my axis. Okay. So this is how we can create our axis using subplots, and this is our 1D array. Okay. Now let's create 2D array. Okay. 2D array. For that I am creating 2x2 array. Okay. 2x2 matrix. And that is 2D array. Okay. Now again, let me write just a minute. Python. Okay. So first of all, I am importing my Matplotlib. Then my figure would be 2 of 2, 2 row, 2 column, right? Now as this is my 2D array, so I cannot access my axis as ax of 0, ax of 1 like this. I have to pass row and column both. Okay. So as I told you, I have already shown you in my theory how to find out the position of the axis in case of 2D array. Okay. So always it starts from 0. In whatever row or column, both will start from 0. So for first position, my row is 0 and my column is also 0, right? In my second axis, first row is 0 and column is 1, right? It is, always remember, it is goes from left to right and top to bottom. Okay. So this is my first one, this is my second one. For third one, what is my row? That is 1. Okay. And my column is 0. And in the same way, my fourth is Fourth one is my row is 1 and my column is also 1. Okay. Now let me change the value. Right. So this is my 2 up 2 matrix and 2D array. Okay. Now in order to access my each axis, as this is my 2D array, so I have to pass row and column. Okay. And rest are same. Now if I execute, now see. Okay. So this is my 2 cross 2 matrix, that is 2D array. Okay. I am creating using subplots. Now the flexibility, see the flexibility. Suppose there are many number of plots. Okay. Now for that, in case of subplot, you cannot handle this canvas size, right? But in case of subplot, you can handle this canvas size using fixed size. Okay. Now if you pass any parameter, suppose 10, 5, and then execute, now see your canvas size gets changed. Okay. So based on your number of graphs, you can change your figure size so that all the element gets properly fitted in your canvas. Okay. That is why subplots is flexible. Okay. Now as I told you, you can execute this 2D array using another way, that is converting it in 1D array. Okay. Converting it in 1D array. Then what you have to do? Now just you have to write ax equal to ax dot flatten. Okay. Flatten. Okay. Ax dot flatten. So using this flatten function, you can convert your 2D array into 1D array. Okay. Now as it already converted in 1D array, so you don't need to pass row and column. Okay. You just have to write ax of 0, ax of 1, something like this. And as this in whatever we have done in 1D array. Okay. So we have to pass all my axes like this. Okay. So first one is 0, second one is 1, third one is 2, and fourth one is 3. Okay. Now if you execute, now see, you get the same output. Okay. You get the same output. So this is my 2D array. So we can pass either this like this. Okay. And if you want to execute like this, then you have to, first of all, you have to convert your 2D array into 1D array. Then you have to pass your axis like this. Okay. And both output will be same. Right. Now let's see another example of 3 into 4. Okay. 3 into 4. That is also 2D. Okay. Now again I have to import matplotlib dot pplot as plt. Okay. Now I have to write figure axis plt dot subplots, and here I have to pass my number of rows and number of columns. So what is the number of rows? That is 3, and column is 4. Right. And let me size my figure. Okay. So I have to write figure size fixed size. And here I need to pass, suppose 12, 8. Okay. Now again, just think how to access my each axis. Okay. So first one, what would be the first one? That is 0 row and 0 column. Right. Second one would be 0 column and one 0 row and 1 column. Third one would be 0 column, 0 row and 2 column, right? Because I have 3 rows and 4 columns. Okay, I have 3 rows and 4 columns. So it will go up to 0, 3, right? So this become my first row and 4 column. Okay, in the same way I have to create my second row and third row with 4 column. Okay, now if you have any confusion, let me show you. This is my 3 of 4, right? That means 3 row and 4 column, right? So let's suppose this is my entire canvas. I have 3 rows. That means 1, 2 and 3. 3 rows and 4 column. That means 1, 2, 3 and 4. Okay. So this is my 0 row, 1, 2. This is my column, 0 column, 1, 2, 3. Okay. So is the position of this axis, that is 0, 0. This one 0, 1. This one 0, 2. This one 0, 3. Right. In the same way, what is the position of this axis? That is 1, 0. This is 1, 1. This is 1, 2. This is 1, 3. And for this 2, 0. 2, 1. 2, 2. And 2, 3. Right? So these are the position of each axis. Okay, these are the position of each axis of 3 cross 4 matrix. Okay, so this is my first row and 4 column, and let me plot all my values. Okay, let me copy. For second, I'm copying everything. Okay, so this is my first row and 4 column. Okay, now in the same way I have to create my second row and third row along with my 4 columns. Okay, so let me copy everything. First row, second row and third row. Okay, I have 3 rows. So this is my first row, this is my second row, and this is my third row, and each row is having 4 columns. Okay, now let me change the position. This would be 1, 0. Okay, this would be 1, 1. This would be 1, 2, and this would be 1, 3, and this would be 2, 0, 2, 1, 2, 2, and 2, 3. Right? Now if I write plt.show and then execute, now see, I have 3 row, 4 column. Now see, this is my first row, this is my second row, this is my third row, and each row is having 4 column. First column, second column, third column, fourth column. Okay, you got it? See, here I have 12 plot. Okay, so this figure size is helping me to fit all the plot in my canvas. Okay, so this is how you can plot any number of graphs in your canvas. Now whenever your plot is little higher, then instead of writing this all the position one by one manually, you can write loop function as well. Okay, so if I write the same code using loop, then what we can do, these are common things. Okay, I'm importing my Matplotlib and this is my figure and axis. Now I'm initializing one variable, that is count. Okay, count as 1. Okay, now I'm creating for loop for I in range of 3. Okay, range of 3. This is for rows. Range of 3 means it will 0, 1, 2. Always range function starts from 0 and it will go up to position -1. That means 0, 1, 2. Okay. Now within this for loop, I have to pass another for loop for column, right? J in range of 4. That means it will go 0, 1, 2, 3. Okay. This is for columns. Okay. Now I can write axis I, comma j, because I have to pass my row and column. So my row is I and column is j. So I am passing ax of I, comma j. Okay. Dot plot. Okay. Dot plot. And my first value is common 1, 2, 3. Okay. I'm keeping my x value same for all. Okay. So I'm keeping it as it is 1, 2, 3. And for y value, I'm creating count. Okay. Comma count plus 1 and count plus 2. Okay. That means 1, 2 and 3. Okay. And I increase my count. By 1. That means plus equal to 1. Okay. So this is my row. This is my column. And in each axis, I'm plotting my first x value as same for 1, 2, 3. And for y value, I'm creating count. That means 1, 2 and 3. It will start from 1, 2, 3. And in each loop, my count will be increased by 1. Okay. Now if I write plt.show and now execute, now see, I'm getting the same result. Okay. I'm getting this same result. So if your value is something like this, then instead of writing all the axes one by one, you can write a loop as well. Okay. It will be much easier to write your code. Okay. I'm just showing you different way. Okay. If your value is different, x, y value is different for each plot, then you have to pass one by one like this. But if your value is same like this, if x value is same or y value is same and the rest will be changed, then you can write like this. Okay. So I'm giving all the examples, right? So guys, I hope you understand what is figure, axis and axis. This entire canvas is my figure, right? This each plot is my axis, and each axis is having axis, that is x axis and this is y axis. Okay, this is x axis and this is y axis. So I hope you understand what is the difference between figure, axis and axis and how subplot and subplots works. Okay. Till now we have seen how to plot our chart, right? How to plot our chart. Now we'll see how to customize our plot. Okay. Now see, in this canvas, does this canvas have any titles or labels or legend or grid lines, anything? No, right? So it is, if you present this type of chart to the user, then it is not understandable by the user. Okay, so to make it understandable and to make it more professional, you have to add different type of customization. Okay, like title, labels, legend, everything. Okay, so now let's see one by one everything. Okay, now for that I am creating one folder, module 3. Now creating plot customize. Okay, dot ipyn. Okay, this is my kernel. Okay, now I'm just, first of all, I'm importing, import matplotlib dot pplot as plt. Okay, now first of all I'm creating one simple chart. Okay, that is plot. Suppose month, I'm creating one variable month and providing my list of month. Okay, suppose Jan, Feb, March, and April. Okay, and another variable is sales. Okay, and the value is 100, 150, 200, 300. Okay, now if I want to plot this chart, then I have to write plt dot plot, and I have to provide my x and y value. So this is my x, this is my y. So I have to provide month, comma, sales. And now I have to write plt dot show. Right. Now if I execute, now this is my normal chart, right? This is my normal plot. So this plot doesn't have any kind of title, legend, everything, right? Now customize this plot. Okay. Now first of all, let me add title. Okay, title. Okay, so now in order to add my title, you have to write plt dot title. Okay, plt dot title, and here I have to pass my title. Okay, suppose monthly sales change. Okay, suppose this is my title of this plot. Okay, now if I execute, now see, my plot is having its own name, that is monthly sales trend. Okay, now what we can do, we can also customize our title as well. Okay, you can customize our title as well. Now if I want to customize your title, then you can provide one by one all the different type of function. Okay, suppose you want to change its font size. Okay, so you write font size, then you can pass suppose 16. Okay, now suppose I want to change this color of this title, then I have to write color. Okay, and suppose blue. Okay, and I want to change the weight of this font. Okay, weight of this font. For that I have to write font weight equal to suppose bold. So that means I want to make my title as bold. Okay, now if I execute, now see, my title font size gets increased and it gets bold, and the color of this title becomes blue. Okay, so this is how you can customize your title of the chart. Okay, now next we see axis label. Okay, axis label. So which one is the x axis and which one is the y axis? Does it provided over here? No, nothing, no axis is mentioned over here. So in order to mention this axis, what you can do? I'm just taking the same example. Okay. Make it Python. Now this is my title. Now I want to make this month. Okay, this month as x-axis and these cells as y-axis. Okay, so for that I have to write plt dot x11. Okay, plt dot x11, and here I have to pass the name, that is month. Okay, and plt dot y11, and here I want to pass cells change. Okay, cells change. So basically this is my x-axis and this is my y-axis. Okay, so I am to just give this the name of this axis. Okay, so I have provided month and then x level as cells chain. Okay, now if I execute, now see, in my x-axis I have my months, so I have named this as month, and in my y-axis I have cells, so I have named it as cells chain. Okay, and this is my title as well, right? So this is how you can provide the title and level of axis level of your chart. Okay, next we'll see legends. Okay, legends is basically when multiple cross exist. Okay, when multiple cross exist, then legend tells what each line means. Okay, now for example, I am creating another example. Okay, this will be Python. Okay, now suppose Sam. Okay, 1, 2, 3, 4. Okay, this is my one variable, or I can write x. Okay, this is my second variable, that is sales of 2025. Okay, sales of 2025, and I just provide 10, 20, 30 and 40. Okay, and I just mentioned sales of 2026 is 15, 25, 35, 45. Okay, now I want to plot two lines. Okay, one is x, for one line my x is this and my y is this, and the second line my x is this and y is this. Okay, so first one would be plt dot plot. Okay, now here my x is x and my y is sales 2025. Okay, and my second one is plt dot plot. My x is x and y is sales of 2026. Okay, now if I just write plt dot show, and I can give title plt dot title sales chain. Okay, now if I just execute, now see, I'm getting these two lines. Okay, I'm getting these two lines. One is x and sales 2025 and another is x and cells 2024, 2026, right? So everything is okay. But can you say which line is for 2025 and which one for cells 2026? So is this possible to say by just watching these two lines? No, right? So in order to understand, we have to put legend. Okay, we have to put legend. Which line which line is for which year? Okay. So for that, what we have to do? We have to write these for my cells of 2025. So I have to pass label. I have to pass label equal to, I just need to pass 2025. Okay. And for here, label, just write 2026. Okay. I'm just giving the legend 10. For this one, I just pass 2025, and for this one, I just pass 2026. Okay. Now, now I have to put plt.legend. In order to execute my legend, I have to pass plt.legend. Okay. Now if I execute, now see, this orange line is 2026 and this blue line is 2025. So it is very much easy to understand which line is represent which data. Okay. Which line representing which data. That is why we need to use this legend. Okay. Now you can change this position of this legend. Okay. If you want, you can change the this position of this legend. Now, for example, if I want to change it, if this is upper left, okay, this is my upper left. So if I want to keep it upper right, okay, upper right, then just I have to pass LOC equal to upper right. Okay. Now if I execute, now see, this comes to this side. Okay, upper right. In the same way, if I want to keep it like here, then you have to write lower left, and if you want to put over here, over in this question, then you have to write lower right. And also, if you want to place it in center, then you can also write center. Now I show you this. Okay, this is my upper left, upper right is done. Upper left was default. Okay, upper left was default, right? Now upper right is done. Now lower left. Okay, lower left. Now see, this is my lower left. Now lower right. Now see, this is my lower right, and another is center. Now see, it comes to the center position. Okay. So accordingly, based on your requirement, you can place your legend whatever you want. Okay. I am keeping at upper left. Okay. Okay. Fine. Now next is grid line. Grid line. Okay. So basically, grid lines improves readability. Okay. Now I'm taking the same example. So to create our grid line, just you have to pass plt.read. That's it. Okay. Now if you execute, now see, it is my grid line. Okay. So it basically improves my readability. Okay. Now if you want, you can also customize your grid. Okay. Customize your grid. Now suppose I want to change the color and to change the color of this grid. Okay. So for that I have to write color Now for example, I want to make it blue. Okay. Now I want to make my line style. Okay. I want to make my line style as dash. Okay. Then I have to put line style, line is line style equal to just up to pass to dash. Okay. So it will create dotted line. Okay. And I want to make my line width 0.5. Okay. Now if I execute, now see, my grid line becomes blue and it's become dotted. Okay, it is become dotted and the line width becomes 0.5. Okay, so these are you can customize your grid. Okay, basically you can style your grid. Okay, next we will see axis limit. Axis limit. Okay, basically axis limit control the visible range. Okay, control the visible range. For example, suppose import matplotlib dot pplot as plt. Now I'm getting one example. Suppose plt dot plot and my x is 1, 2, 3 and my y is 20, 50, 80. Okay. Now if I just plt dot show, if I just run plt dot show, then it is giving me this something like this, because here in case of x, my highest point is 3, so it is coming up to 3, right? And for x-axis, my highest point is 80, so it is coming till 80. Okay, it is coming till 80 in my chart. Okay, now if I am to control my level, then I have to use this axis limit. Okay, for example, first of all, I want to see this y level up to 100. Okay, up to 100. Then what we have to do? We have to just pass plt dot ylim. Okay, as I want to increase the visibility limit in y-axis, so I have to write y and lim. That means limit, y limit. Okay, and here I have to pass from and to. Okay, so from where I want to start with, 0 and I want to go till 100. Okay, so I have to pass from 0 to 100. Okay, here only the digit, whatever the value I have provided, 20, 50, 80, so it is coming from this range 20 to 80. Okay, now I have provided my y limit as starting from 0 up to 100. Okay, now if I execute, now see, my x is as it is. Okay, but my y visibility becomes increased, so it is starting from 0 and it will go up to 100. Okay, so I am basically controlling my visibility limit. Okay, in the same way, here it is 1 to 3, right? 1 to 3. Now if I am to see 1 to 10, suppose I am to see 1 to 10. Okay, then I need to write plt dot x limit, because this is my x-axis, so I have to write x limit, lim. Okay, and here also I want to start with, suppose I want to start with 1. Okay, I want to start with 1 and I want to go till 10. Now if I execute, now see, my x-axis become from 1 to 10 and it is 0 to 100. Okay, if I make it 0, okay, right. Okay, so my x-axis become 0 to 10 and y-axis becomes 0 to 100. Okay, so these are, we can set our y-axis and axis limit. Okay, this is called axis limit. So basically to increase my visibility. Okay, next is tick customization. Okay, tick customization. So what is tick? This value, this 0, 2, 4, 6, these are the tick. Okay, these are the tick. Now we can also customize these tick. For example, I'm taking this same example. Here I'm not using this limit. Okay, I'm just simply executing this plot. Okay, now my x value is 1, 2, 3. Okay, there is 1, 2, 3, 1, 2, 3. See, as my y value is higher, so in x-axis my entire data got splitted. Okay, so it becomes 1, 1.25, 1.5, 1.75, 2, and so on. Okay, but my actual value is 1, 2, 3. Okay, now for example, instead of writing 1, 2, 3, I want to represent 1, 2, 3 as, suppose, Jan, Feb, March. Okay, January, February, March. Suppose I am to consider this as my month. Okay, so for that I have to write plt dot x tick, because this is my x axis, so I have to write x tick. Okay, x ticks, and here I have to pass my original value, that is 1, 2, 3, comma, here I want to pass my new value, which I want to replace with 1, 2, and 3. Okay, so for example, Jan, Feb, and March. Okay, now if I execute, now see, my 1 becomes Jan, my 2 becomes Feb, and my 3 becomes March. Okay, so basically I'm just renaming my values. I'm just renaming my values using x ticks. So ticks basically these values, and if I want to change my name of these values, then I need to use these ticks. Okay, in the same way you can rename your y ticks as well. Okay, now you can also rotate this tick value. Okay, you can rotate this tick value. So for rotating, you have to dash write rotation, and you have to provide the value at which degree you want to rotate your ticks. Okay, suppose I want to rotate it at 45 degree. Okay, so I just mentioned rotation equal to 45. So it is now in simple way Jan, Feb, March. Now if I execute, now see, my Jan, Feb, March gets rotated at 45 degree angle. Okay, 45 degree angle. Now if you make it 90, then it will rotate at 90 degree. See, 90 degree. Okay, so this is how you can rotate your ticks as well. Okay, next we have figure size. Figure size, I've already shown you what is figure size. Basically, figure size is used to control our canvas size. Okay, this canvas size. So if I take this same example and want to change the figure size, then we have to provide, before plotting our plot, we have to pass our figure size. Okay, so I have to write plt dot figure, and here I have to pass my figure size. Okay, suppose I want to make it 10,4. Okay, and all are same, rest are same. Now if I execute, now see, my canvas size gets bigger. Okay, it was by default it was this size. Now I have made it 10,4. Okay, so my canvas size gets changed. So using this plt.figure, I can control my figure size of this canvas. Okay, next we will see how to change style, background style or theme. Okay, background style or theme. Okay, so it basically changes the visual appearance of our chart. Okay, this chart is my normal chart. Okay, white background and something like this. Now if you want to change the style of this chart, appearance of this chart, then we can use our background style or theme. Okay. So, but before that, let me show you how to check how many styles is there in Matplotlib. Okay. So for that, you have to import Matplotlib dot keep lot as plt. Okay. Now you have to write print plt dot style dot available. Okay. Now if you execute, now see, these are the style that is available in Matplotlib. Okay. These are the style or background theme that is available in Matplotlib. Okay. So you can use any of them. Okay. Now, for example, I am taking this same example. Okay. I'm taking same example. Now this is my normal plot. Okay. Now if I want to customize it, I want to use some themes. Okay. Now for that, I have to write plt dot style dot use. Okay. And within this parenthesis, I can pass any of this theme. Okay. Now, for example, I'm just passing. First of all, I'm passing this one. Okay. Now, if I execute, now see, background gets changed. Okay. My chart background gets changed. Now, for example, if I use this one and execute, now see, the background gets changed. Okay. In the same way, if I use this dark background, okay. Now see, my background gets changed. Okay. This is how you can customize your chart. Okay. You can customize your entire style of your plot. Okay. So you can use any of them, right? Now next is saving chart. Okay. Saving chart. That means after creating this chart, if you want to save this chart as a PNG or PDF, then how do I do that? Okay. For that, I'm taking same example. Now I want to save this chart. Okay. So for saving this chart, I have to write plt dot save fee. Okay. plt dot save fee. And here I have to pass my file name. Suppose I want to save it as sales chart. Okay. And I have to provide my extension. Suppose I want to save it as PNG. Okay. And always remember this plt.save figure you have to mention before plt.show. Okay. Now if I execute, now see, in the same path, one and another PNG file gets created. Okay. Now if I click in this one, now see, this entire chart gets saved as a PNG file. Okay. It is saved as PNG file. Now in the same way, if I want to save it, the same file as PDF, then I just need to pass the extension as PDF. Okay. And now if I execute, in the same way, one PDF file gets created over in this path. Okay. Now if I execute, now see, sales underscore chart.pdf file got created in the same path. Okay. See. Okay. So this is how you can save your chart as PNG or PDF. Okay. So guys, I hope you understand how to customize your entire plot or canvas by adding name, title, axis, legend, how to change the theme or style of the background of the chart. Okay, so you just practice it and use any type of customization based on your requirement, right? Now we'll see line plot, that is line chart. Okay, so this is module 4. I'm getting file line plot dot ipynb. This is my kernel. Okay, so basically till now whatever plot we have created in our practical, that is called line plot. Okay, that is called line plot. So first of all, let me import my Matplotlib. Plot as plt. Okay, now I'm creating a simple line plot. Okay, this is my x value 1, 2, 3, 4. Okay, and this is my y 10, 20, 30, 40. Okay, so plt dot plot x comma y and plt dot show. Okay, now if I execute, now this is my simple plot. We have already seen this type of example. So this plot is also called line plot. Okay, that is line chart. Okay, now let me add some labels and titles. Okay, so let me add title, plt dot title, suppose sales growth. Okay, sales growth, and I'm adding my axis label. Okay, so plt dot x label. Okay, in x label I want to mention month. Okay, months, and in y label I want to mention my sales. Okay, now see, this is my title of this chart, and this is my y axis, that is sales, and this is my x axis, that is month. Okay, now I can customize this plot as well. Okay, this line. Okay, I can customize this line as well. So for that, in order to customize this line, what we can do, we can write something. Suppose I want to change my color. Okay, color as red. Okay, and line style, I want to give line style as dash. Okay, double dash, that means dotted type. Okay, now if I execute, now see, my line color gets changed, that is become red and it's become dashed. Okay, dash type of line, right? Now I can add another thing, that is marker. Okay, marker, and here I just need to pass O. Okay, basically markers highlights each point. Okay, each data point. Markers highlight each data point. Now if I execute, now see, this 4 point I have in my data: 110, 220, 330, 440. 110, 220, 330, 440. Okay, so using marker I can just point out my data point. Okay, so these are the few parameters that you can use to customize your lines, your line chart. Okay, now I'm creating two lines. Okay, I'm creating two lines. Let me take the same type of example. Okay, this is my x, this is my, suppose, y1. Okay, and let me change these values 10, 20, 30, 40. Okay, let me keep it as it is, and I'm getting another y2, that is 40, 30, 20, 10. Okay, so I'm to create one line with respect to x and y1, and I'm going to and another line with respect to x and y2. Okay, now I have to plot my second line as well. Okay, this is my first line and this is my second line. Here I have to pass x and y1, and here I have to pass x and y2. Okay, this is my red, suppose, and this is my blue. Okay, and I want to use my legend. Okay, so for that I have to mention level, right? Level, and this one I want to mention as growth, and this one I want to mention as decline. Okay, and I'm keeping rest as it is. Okay, now if I execute, now see, these are my two lines. Okay, one is x with respect to y1, and another is x with respect to y2. Okay, what is legend? Okay, just a minute. I have to mention plt dot legend. Now see, this red line is my growth, that means x and y1, and this blue line is my decline, that means x and y2. Okay, so this is how you can plot any number of lines in your chart. Okay, and you can customize each line based on your requirement. Okay, so this is my basically this is my line chart. Okay, now you can use background style as well, and you can save this chart as a png or pdf. Okay, next we will see about bar chart. Okay, bar chart. So this is our module file. There I'm creating my file bar chart dot ipy only. Okay, so basically bar chart represent data using rectangular bars. Okay, and it is used when we want to compare categories. We want to show some difference between groups, then we have to use bar chart. Okay, so let me select my kernel. Now first of all I'm importing my Matplotlib. Now I'm creating one variable, that is categories. Okay, categories, and this is my list of categories. Suppose A, B, C, and D. Okay, these are my categories, and these are my values. 10, 20, 15, 25. Okay, now in order to create bar chart we have to write plt dot bar. Okay, for line chart we have to use plt dot plot. For bar chart we have to use plt dot bar. Okay, now here I have to pass my x and y, and my x is category and y is my values. Okay, now if I write plt dot show, and now if I execute, now see, this is my bar chart. This is my category A, B, C, D, and these are my value. For A is 10, B is 20, C is 15, D is 25. Okay, so using this bar you can easily compare all the categories, right? You can easily compare all the categories. So whenever you need to compare different type of categories or groups, then you have to use this bar chart. Okay, that is why bar chart is also called comparison tool. Okay, now let me add some titles and labels. Okay, so plt dot title, I just mentioned sales by category. Okay, and plt dot x label, in x label I have my category, so I just mentioned category. And in y label I have my values, so I just mentioned sales. Okay, now if I execute, now see, sales by category, my chart name is sales by category, and this is my sales, y axis is my sales, and x axis is my category. Okay, now this by default is blue, this bar color is blue. Now if you want to change the bar color, then you can do that. Then you have to write in field.bar, you have to provide one parameter, that is color. And suppose I am to mention as orange. Okay, now if I execute, now see, all bar becomes orange color. Okay, now suppose you want to make different bar in different color. Okay, different bar in different color. Then what you can do, you can pass one parameter, one variable, that is suppose colors. Okay, colors, and suppose one is red, another is blue, another is green, and another is purple. Okay, now here in this color parameter, instead of hard coding my color name, I just need to pass my colors. Okay, I just need to my colors variable. Now if I execute, now see, my A becomes red. Okay, B becomes blue, C becomes green. Okay, and D becomes purple. Okay, so these are how you can customize your bar color, everything. Okay, now you can change your bar width as well. Okay, so there is another parameter, that is width. Okay, suppose 0.5. Now if I execute, now see, my width of the each bar gets changed. Okay, so you can customize your bar based on your requirement. Okay, next we will see multiple bars. Okay, multiple bars, that is also called group bars, group bar chart. Okay, group bar chart. Okay, so multiple bars, that is called also group bar chart. Okay, before that let me show one more thing. This is my vertical placement. Okay, now for here I have only 4 categories and my labels are very small. Now sometime in your project your labels might be long. Okay, your labels might be long and you have many categories. Then you, instead of vertically, you have to provide your bars in horizontal way. Okay, in horizontal way. Then you have to just write bar H. Okay, instead of bar, you just have to pass bar H. That's it. Now if I execute, bar got multiple values or argument. Okay, instead of width, I have to pass height. Okay, I have to pass height. When we place our bar in vertical way, then we have to provide width, and when we place our bar in horizontal way, then we have to provide height. Okay, now if I execute, now see, my same bar got placed in horizontal way. Okay, so these are how you can place your bar in vertical way or horizontal way based on your requirement. Okay, now comes to the multiple bars. Okay, now I'm creating another example. Here I'm importing my Matplotlib dot plot as plt. Okay. Now I'm creating X. I'm creating a range of number. Okay. For that, I need to import NumPy. Okay. Import NumPy as np. Okay. Now my X value is np.arrange and I provide just 4. Okay. This is my X value. Now suppose I am creating another variable, that is sales of 2025. Okay. This value is 10, 20, 15, 25. Okay. And another value is sales of 2026. Here I just provide 15, 25, 20 and 30. Okay. That means I want to create bar with respect to X and sales 25 and another bar with respect to X and sales 2026. Okay. Now I have to plot my bar. I have to plot my both bar. So this is my first bar, that is plt.bar. Here I have to provide my X and Y is sales 2025. Okay. And I want to mention the width as 0.4 and I want to mention my label, that is legend. Okay. Label equal to, I just mentioned 2025. Okay. This is my legend. And in the same way, I just pass sales 2026 and width is 0.4 and label is 2026. Okay. Now I am to use X ticks. Okay. Because in my X axis, what is the value of will be shown in my X axis, that is 0, 1, 2, 3. As I write np.arrange of 4, that will print as 0, 1, 2, 3. Okay. These 4 value will be printed in my X axis. Okay. So instead of this 0, 1, 2, 3, I just want to print ABCD. Okay. So for that I have to change my ticks value. So for that I have to write X ticks. To change my ticks value, I have to write plt.xticks and here I have to pass my original value, that is X, and here I have to pass my new value that I am to replace with. Okay. That is A, B, C and D. Okay. And as I have used label, so I have to write plt.legend. Okay. And plt.show. Okay. Now if I execute, now see, you are getting only one bar, that is 2026, but you are not 2025 bar is not visible. Why? Because it gets overlap. Okay. Because in both bar my X position is same, so it gets overlap. So for proper visibility, I just need to shift my this bar, this 2025, this bar just 0.2 in the left side. Okay. I'm just shifting my bar in left side by 0.2. Okay. And my second bar, I want to shift my second bar to the right side. So I have to just write plus 0.2. Okay. So using minus 0.2, I'm just shifting my bar to the left side, and plus 0.2, I'm shifting my bar to the right side. Okay. So there will be no overlapping. Okay. Now if I execute, now see, my all bar are properly visible. So this is my this blue is my 2025 and my orange is 2026. Okay. So this is my multiple bar. Okay, these are multiple bars. That is called group bar. So in this way, you can place any number of bars on your graph. Okay. Now you can also align this bar in horizontal way. Okay, just mentioning bar edge. Okay, you just put bar edge, then this bar will be aligned in horizontal. Okay. Now next, as slowly we are entering into the advanced part, so it is always recommended to use the object oriented approach. Okay, which is the new approach. See, these all are traditional approach. Okay, this is the old approach, but in new approach, that is called object oriented approach, and that is axes and subplots. Okay, that is using axes and subplots. Okay, so if I consider the same example, this is my traditional method. Okay, and this is my new method. Okay, this is called object oriented approach. Okay, now we have to use, for object oriented approach, we have to use axes and subplots. Okay, so for that I have to just write figure axis plt dot subplots. Okay, now this is my axis gets created. Now instead of plt dot bar, I have to use axis, that means ax dot bar. Okay, and ax dot legend, and that's it. Okay, now if I execute, now see, I'm getting the same result. Okay, I'm getting the same result. Okay, but this is the pro level approach. Okay, this is called object oriented approach, and this is the pro level. This is the new technique. Okay, and this is the traditional method, that is old method. So in advanced part, always recommended to use this technique. Okay, using axis and subplots. Okay, so I hope you understand how to create bar chart and when we need to use our bar chart. Okay, next we will see about scatter plot. Okay, scatter plot. Okay, a scatter plot shows relationship between two variables. Okay, relationship between two variables. Okay, so basically scatter plot represent relationship between two variables. Okay, and scatter plot always display the value as point. Okay, as points. Let's remember. Now, for example, suppose we have x height. Okay, and we have y weight. Okay, now I have 160, 170, 180. Okay, and in weight I have 55, 65, 75. Okay, now if we represent this value in our chart, okay, then suppose this is weight and this is height. Okay, suppose this is 100 to 200, and this is 10 to 100. Okay, so first point would be 160, 55. So weight would be 55. Suppose 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, this is 100. And this is 100, 110, 120, 130, 40, 50, 60, 70, 80, 90, and this is 200. Okay. Now, if I plot this height, this 160 height and weight 55, then where will be this point? This is my weight 55, 20, 30, 40, 50, 50. So it will around here, and height is 160. So 1, 2, 3, 4, 5, 6, somewhere around here. Okay. In the same way, 160, 65. So it will go somewhere around here. 180, 75. It will go somewhere around here. Okay. So basically, this is my 160, 55 point. This is my 170, 65 point. And this is my 180, 75 point. Okay. So this is my scatter plot. So this scatter plot showing the relationship between weight and height, how they are connected, how they are related to each other. This scatter plot is showing that relationship. Okay. And all the place, all the value, that is x and y, is represented as dot, that is point. Okay. All the values will be pointed as point, right? So this is a scatter plot. Okay. Now when we need to use this scatter plot to find correlation. Okay. Correlation, that means how this x and y related to each other. Okay. Now we can detect pattern. Okay. We can detect pattern, how this all the points are connected. Okay. We can find this pattern. Also we can identify outlier. Okay. If any point is there which is completely different to each other, that is called outlier. Okay. So we can find that outlier as well using this scatter plot. Okay. Now one more thing that you need to understand, that is correlation. Okay. Correlation. So what is correlation? Correlation basically how two variables move in relation to each other. Okay. How they related to each other. Suppose I have x and y. Okay. If my x increase and at the same time my y also increase, then it is called positive correlation. Okay. Now when my x increase and y decrease, that is called negative correlation. Okay. And when there is no clear relationship between x and y, that means if x up, then we cannot predict what is y. Okay. What is the trend of y, then it is called no correlation. Okay. So when my x value increase and y value increase, that is called positive. When my x value increase and y value decrease, that is called negative. And when there is no relationship, whether my x is increasing or decreasing, if y value is not, it doesn't depend on my x value, then it is called no correlation. Now if I give you some practical example of positive correlation. Okay. Positive correlation. Suppose we have a x, that is study hour. Okay. Study hour. And y is marks. If I study for 1 hour, then my marks is 40. If my study hour is 2, then 50. 3, 60. 4, 70. 5, 80. Right? That means if I increase my study hour, then automatically my marks is getting increased. Okay. Right? So this is positive correlation. Positive correlation. Because my x is, when my x is increased, automatically my y is increased. Okay. Now negative correlation. My x is suppose exercise hour. Okay. And y is body fat. Now if I exercise for 1 hour, then my body fat is 35. If I exercise for 2 hours, then my body fat will be 30. If I exercise for 3 hours, then it becomes 25. 4 hours, it becomes 20, like this. That means how long I increase my exercise time, my fat will decrease. Okay. My fat will decrease. So this is called negative correlation. Okay. So when my exercise hours, that means X is getting increase, my body fat, that is Y, is getting decrease. Okay. And if I plot this type of value in my scatter plot, then it will be like this. Okay. It will be like this. And in case of positive, it will be like this. Okay. And the next one is no correlation. For example, I have X is student shoe size. Okay, shoe size. And another I have student marks. So is there any relationship between student shoe size and student marks? No, right? So this is called no relationship, because might be the shoe size is suppose 8, one student is having 9, another is having 10. This student might be having marks 80, this might be having 70, this might be having 90. Okay, so there is no direct relationship between shoe size and student marks, right? So this is called no correlation. And if I plot this type of value in my scatter plot, then it will be something like this. Then if the value will be randomly placed over here. Okay, there is no relationship between all the points. Okay, so this is called no correlation. Okay, so now I'm getting my next folder, that is module 6. Okay, and here I'm creating my file scatter plot.ipynb. So I'm selecting my kernel. Okay, so I'm creating a basic scatter plot first. Okay, so first of all, I have to import my matplotlib matplotlib.pplot as plt. Now I'm getting my two values, that is one is X, this is 1, 2, 3, 4, 5. Okay, and another is Y, 10, 20, 30, 40, or I can write something 10, 20, 15, 25 and 30. Okay, so these are my two values. Now in order to create my scatter plot, we have to write plt.scatter. Okay, plt.scatter, and here I have to pass my X and Y. This is X and Y. Okay, and then I have to write plt.show. Now if I execute, now see, this is my scatter plot. So all the points is my X and Y. So this is my first 1 and 10. This point is my 1 and 10. The second one is 220. That means this is my 220. Okay. Third position is 315. So this is my 315. Okay. And so on. Okay. So each point represent the value of X and Y. Okay. Each point represent the value of X and Y. So it basically, it is this scatter plot basically showing the relationship between X and Y, how they are related to each other. Okay. Now I can add some labels. Okay. First of all, let me give the title. Okay. Title. Let me consider this graph as height versus weight. Okay. So I'm just giving title as height versus weight. Okay. Now plt.x label, I just labeling my axis. Okay, so x label is my height, and my y label is weight. Okay, see, height versus weight. So my x label is height and y label is weight. Okay, now let's try to customize our plot one by one. Okay, so first of all, I need to change this color. This is by default this is blue. So suppose I want to change this color. Okay. So for that I have to write color, and I have to pass any color. Suppose red. Okay. Now if I execute, now see all the point becomes red color. Okay. Now if I want to increase this size of this point, then I have to pass another parameter, that is s. Okay. Now if I write s equal to 100 and execute, now see the size of the all point gets increased. Okay. Size of all points gets increased. Now suppose I want to change the transparency of each point. Okay. I want to change the transparency of each point. Then I have to use another parameter, that is called alpha. Okay, alpha. Now if I pass alpha equal to 0.5, now this is 100. Okay, this is full, that is 1. Now if I write alpha 0.5, then it will decrease the transparency. Now see, the transparency of this all point got changed. Okay. Now suppose I want some gradient color. Instead of a single color, I want some gradient color. Okay, this is little advanced part. Okay. Now suppose I want some gradient color in each point. Okay. So for that we have to write cmap equal to viridis. Okay. And we have to pass another third variable, that is color variable. Okay. I have to pass another variable, that is color variables, and here I have to pass some values, that is basically just like temperature. Okay. Suppose 100, 200, 300, 400 and 500. That means 100 is light color and 500 is deep color. Okay. So this color variable I have to pass, and then I have to map this color. Okay. So to map I have to write c equal to colors. Okay. And cmap equal to this. So automatically this color temperature gets assigned over here, and it will show, instead of a single color, it will show some gradient color. Okay. Now if I execute, now see, this is my gradient color. So let me do one thing. Let me remove the alpha. Okay, because it's changing the transparency. So if I remove that alpha, now see, this is my gradient color. Okay. So this is my light color, this is my deep color. Okay. So this is how you can customize your scatter plot as you want. Okay. Now next, see multiple scatter group. Okay. This is called multiple scattered group. Okay. Now I'm importing my Matplotlib. Matplotlib.pplot as plt. I'm getting x1, 1, 2, 3. Okay. And y1, 10, 20, 30. Okay. Now I'm creating x2. Okay. 1, 2, 3 and y2. That is 30, 20, 10. Okay. Now I have to plot these two variable. Okay. These two relationship. One is x1, y1. Another is x2, y2. So I have to plot two scatter plot, right? So for that I have to write plt dot scatter, and in first scatter I have to pass my x1 and y1. Okay. And I just giving one color. Okay, one color. Suppose this I'm passing blue. Okay. And I'm passing label. So I am to make my legend. Okay. So for that I have to write label. Suppose this is group 1. Group 1. In the same way, I have to create another scatter plot. Here I have to pass x2 and y2. Now I'm giving color as red. Okay. And this is my group 2. Okay. Now I have to write my legend. Okay. Then I have to write my plt.show. Okay. Now if I execute, now see, this blue is my group 1 is this one, and this is my group 2, this orange one. So this one. So this is my, these orange points are my x2, y2. Okay. So this is my x2, y2, and this green points is my x1, y1. See, you might be thinking there is only two blue points. No, there is 3 blue points. Actually, if you see my this number 220 and 220, the both are same. So here my blue point gets overlapped by this orange point. Okay, but actually there are three blue point and 3 orange point. Okay, so don't be confused. Okay, so this is how you can plot any number of scatter. Okay, you can plot any number of scatter plot in your chart. Okay, next we'll see correlation. Okay, correlation. Okay, so first one is positive. Okay, positive correlation. That means when my x increase, then my y also get increased. Okay, now let me import my Matplotlib. Now I'm creating my 2 points. One is study hour. Okay, study hour. 1, 2, 3, 4, 5, and another is marks. 40, 50, 60, 70, 80. Okay. Now I am plotting my chart, that is plt.scatter, and here I am passing x and y. Okay, that means study hour and marks. Okay, now I'm giving title plt.title positive correlation. Okay, and label plt.xlabel, that is study hour, and plt.ylabel, that is marks. Okay, now if I write plt.show, now see, here positive correlation. This is my study hour, x-axis is my study hour, and y-axis is my marks. Now when I'm studying for 1 hour, then I'm getting 40 marks. When I'm studying for 2 hours, then I'm getting 50 marks. When I'm studying for 3 hours, then I'm getting 60 marks. When I'm studying for 4 hours, then I'm getting 70 marks. And when I'm studying for 5 hours, then I'm getting 80 marks. Okay, so as my study hours gets increased, automatically my marks gets increased. Okay, so this is called positive correlation. Okay, this is called positive correlation. When x is getting increased, automatically my y is getting increased. Okay, Next is negative correlation. I'm trying to take same type of example. Here, let me write exercise hour. Okay, exercise hour and body fat. Okay, so my body fat will be something like 35, 30, 25, 20, 15. Okay, that means my exercise hour is getting increased, so automatically my body fat getting decreased. Okay, so this would be exercise hour and this would be body fat. This is called negative correlation. This is my exercise hour and this is my body fat. Okay, now if I execute, now see, when I'm exercising for 1 hour, then my body fat is 35. When I'm exercising for 2 hours, then my body fat getting decreased and it is 30. When I'm exercising for 3 hours, then it is 25. When I'm exercising for 4 hours, then my body fat getting decreased and it becomes 20. And for 5 hours, it is 15. So how, as I increasing my exercise hour, automatically my body fat getting decreased. Okay, my body fat getting decreased. That means when my X is getting increased, my Y is getting decreased, right? So this is called negative correlation. Okay, and the next one is no correlation. Okay, suppose here I have my two sides. Okay, and here any number, suppose 6, 7, 8, 9, 10. Okay, and here my marks. Okay, marks is something like 80, 45, suppose 90, 60, 72. Okay, so this is my suicide and this is my marks. So is there any relationship between suicide and marks? No, there is no relationship between suicide and marks. Okay, now here I have to pass my suicide and in Y I have to pass my marks. Okay, this is no correlationship. Okay, in X label I have suicide and in Y level I have marks. Now if I execute, now see, my point is here and there. There is no relationship between all the points. Okay, this is called random scattered points. Okay, this is called random scattered points because there is no relationship between these two points, that is suicide and marks. Okay, so I hope you understand what is positive, what is negative, and what is no correlationship, and how to implement all these things. Okay, now as I told you, as we have already entered in advanced part, so it is always recommended to use our new approach. Okay, because these are old technique. Okay, these are old technique, so it is always recommended to use our new approach, that is object oriented approach. Okay, so let me take the same example. Okay, let me write object oriented approach. Now, in order to use our new approach, that is object-oriented approach, we have to use axis, okay, figure, axis, and subplots. Okay, we have to create our figure axis using our subplots. So for that, what we have to do? We have to write figure axis plt dot subplots. Okay, and instead of writing plt dot scatter, I have to write axis dot scatter. Okay, and rest are same. Okay, rest are same. Now if I execute, now see, I'm getting the same result. Whatever I am getting from this old approach, okay, whatever I'm getting from this old approach, this one is my old approach. So this is my output. So I'm getting the same output. I'm getting the same output using this new approach. That is object-oriented approach. Okay, and it is always recommended to use this object-oriented approach. Okay. So I hope you understand how to create our scatter plot, how to create multiple scatter plot, how to create different type of correlation. Okay, and how to use our scatter plot in using object-oriented approach. Okay. Next we have histogram. Okay, histogram. So basically, histogram is a histogram shows the distribution of numerical data. Okay, distribution of numerical data. So it basically groups values into range called bins. Okay, called bins. It groups the value. Okay, it groups the value that is called bins and shows how many values fall into that range. Okay, so for example, I have marks. Okay, I have marks data. Suppose 45, 50, 52, 55, 60, 61, 62, 65, 70, 75, 80, okay, 85 and 90, something like this. Okay, so instead of checking each number manually, what Histogram do? Histogram basically groups our entire numerical data. Suppose it groups 40 to 50. Okay, it groups 40 to 50. This is one group. Okay, and it will show how many student lies in this group, in this range. Okay, in this range. Okay, after that it will create another group that is 50 to 60. Okay, and it will show how many student lies in this range. Again it will create 60 to 70, then it will create 70 to 80, then it will create 80 to 90, something like this. Okay, so it basically groups all my numerical data. It groups all my numerical data and shows how many values fall into this range. Okay, into this group, right? So when you write something plt.hist in order to create our histogram, you have to write plt.hist and you have to pass your value. Okay, that is marks. Now if you don't pass anything in this parenthesis, then automatically Python Matplotlib automatically create the group by its own. Okay, it automatically creates all the groups. Okay, it might be 5, it might be 10. Okay, it automatically creates. Okay, and all the groups is called bins. Okay, all the groups called bins. But if you specifically want, if you want suppose 5 bins or you want something 8 bins, okay, then you have to just pass in this parenthesis. After marks you have to put a comma. Okay, after marks you have to put a comma, then you have to mention bin. Bins equal to, suppose you want 8 bins. Okay, that means when you pass bins equal to 8, then explicitly you are instructing Matplotlib to group my entire data into 8 group. Okay, into 8 group. That time this Matplotlib might be it might be split all the data like something 40 to 55, 55 to say 65, okay, 65 to 72, something like this. Okay, basically it will create 8 groups. That means 8 bins. Okay, and it will distribute, it will split all the data by its own, but it will create 8 bins. Okay, if you mention 5, then automatically it splitted all the data in 5 bins. Okay, it will split by its own. Okay, but it will create 5 bins. If you mention 10, then it will split all the numerical data in 10 bins. Okay, in 10 bins. So based on your requirement, you can mention your number of bins, whatever you want. Okay, and another is, if you can explicitly mention what should be your group range. Okay, for that, suppose I want my group should be like this: 40 to 50. Okay, one is 50 to 60, one is 60 to 70, like this. Okay, then you can mention like this: plt dot hist. Here you have to pass your marks, and here you have to pass bins, and here you have to pass your enter data, something like this. If you want 40 to 50, then I want 50 to 60, then I want 60 to 70, then I want 70 to 80, then I want 80 to 90, something like this. Okay, now when you mention something like this, automatically Matplotlib explicitly group the entire data like in this sense: 40 to 50, 50 to 60, something like this. Okay, so if you don't pass your bins, then automatically it will split the entire data by its own. Okay, number one. Number two, if you want any specific bins, number of bins, 5, 8, 10, whatever it is, then you have to mention bins equal to, then you have to provide your number. And if you explicitly mention what should be your bins group, okay, what should be your bins group, that means what should be the range. Okay, then you can explicitly mention something like this: 40, 50, 60, 70, like this. Okay, this is how you can customize your bins. Okay, so I'm creating my new folder, that is module 7. Okay, the new file is histplot. Okay, histplot.ipynt. Now this is my kernel. So I'm creating simply histogram first. Okay, so for that I have to write import matplotlib.pplot as plt. Now suppose I'm getting one value, that is marks. Okay, now here I'm passing some values: 45, 50, 52, 55, 60, 62, 65, 70, 72, 80, 85, 90. Okay, this is my data. Now, in order to create my histogram, we have to write plt.hist. Okay, and here I have to pass my data, that means marks. Okay, now I have to write plt.hist. Sorry, plt.show. Okay, now if I execute, now see, this is my histogram. Okay, this is my histogram. So automatically my entire data get distributed and it creates groups. Okay, it create groups. That means these are the bins. Okay, this is the first bin, this is the second bin, this is the third bin, this is the fourth bin, fifth, sixth, like this. Okay, so by creating bins, their entire my numerical data get splitted into groups. Okay, my entire data get splitted and it creates groups, and these bins are the groups. Okay, so this is the entire range, this is the entire distribution. Within this, my entire value, all the value, my entire value is lies. Okay, so this is my distribution. And in histogram, we have to just pass one value, that's x value. Okay, and this y value automatically gets created. This is basically, this y value is called frequency. Okay, this frequency. So in this frequency, my entire value is lies in this frequency. That is, in this case, it is 0 to 2. Okay, so in this frequency, my entire data is basically lies. Okay, now let me first add some labels. Okay, title distribution of student marks. Let me write x level. Okay, x level, and x level is my marks range, right? And my y level is my frequency. Okay, y level is my frequency. Now see, distribution of student marks, this is my marks range and this is my frequency. Okay, now let me customize my this histogram. Okay, that means these bins. Okay, now for that I have to use some parameter. Suppose I want to change the color, so for that I have to write color, and suppose I am using sky blue. Okay, sky blue, and or first of all let me use green. Okay, now if I execute, now see, my bin colors gets changed and it's become green. Okay, now there is another parameter, that is edge color. Okay, edge color. Edge color, basically edge color is used basically border color. Okay, all the border color of these bins. Okay, so to put any border color, we have to use edge color parameter. Okay, and suppose I just use black. Now if I execute, now see, all the border gets colored by black. Okay, next one, another parameter we have that is very much important, which basically used in statistics. Okay, or machine learning statistics, this parameter gets used, that is density. Okay, density, and you have to mention density equal to true. And now if I execute, now see, this frequency, previously it was 0 to 2, that was normal frequency. Now this y-axis become probability density. Okay, probability density. So this is called probability distribution. So it is normally used in machine learning or statistics. Okay, so whenever you need to find out the probability distribution of your data, then you have to use something like this. You have to just mention density equal to true, and it will automatically give the probability distribution of your entire data. Okay, now here when I'm creating my histogram, then I did not mention any number of bins. Okay, so automatically Matplotlib creates all the bins, that means range, by its own. Okay, so it creates 1 2 3 4 5 6 7 8 9 10 bins. Okay, so it basically splitted our data in 10 bins. Okay, now suppose we want, instead of 10 bins, we want 5 bins. Okay, then just we have to mention bins equal to 5. Okay, now what happened? Now when I explicitly mention I want 5 bins, then my entire data splitted in 5 groups. Okay, and it will create 5 bins. Okay, now if I execute, now see, I am getting 5 bins, 1 2 3 4 5. So my entire data grouped in 5 bins. Okay, in the same way, if you want 8, then just execute. Now see, 1 2 3 4 5 6 7 8 8 bins gets created. Okay, these are how you can create any number of bins on your data based on your requirement. Okay, and Next we have if you want explicitly, if you want your range has to be 40 to 50, 50 to 60, 60 to 70, like this, then instead of mentioning the number of bins, you just mention the range. Okay, suppose you want your bins should be range between 40 to 50, then you have to mention like this: 40 comma 50, then 50 to 60, then 60 to 70, then 70 to 80, then 80 to 90. Okay, now if you explicitly mention this, then automatically your bins will be grouped like this. See, 40 to 50, 50 to 60, 60 to 70, all the bins is splitting in this range. Okay, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. Okay, so if you don't pass any number of bins, then automatically Matplotlib will create all the bins by its own. It will split your data by its own. If you mention explicitly any number of bins, then it will create that number of bins and your data will be splitted in that number of groups. And if you want any explicit range of group, then you have to mention something like this. Okay, then automatically these bins will be created within your required range. Okay. Now let's create multiple histogram together. Okay, multiple histogram. Okay, now let me import my Matplotlib. Then I'm creating one parameter, sorry, variable, that is marks of class A. Okay, marks of class A, and this is my range: 45, suppose 45, 50, 55, 60, 65, 70. Okay, and I'm creating another variable, that is marks of class B. Okay, now this is my range of marks, that is 50, 55, 60, 75, 80 and 85. Okay, now I have two data, so I have to plot, I have to create two histogram. Okay, so I have to write plt.hist, and in first histogram I have to pass this one. I have to pass my class A marks. Okay, now I'm giving one color, suppose this is red. Okay, and I can use my alpha. Okay, alpha is basically to change the transparency. Okay, to change the transparency, so I can use my alpha equal to 0.5, and I can use my legend. Okay, for that I have to write label equal to class A. Okay, in the same way I need to create second histogram, and here I have to use class B. Now suppose this is green. Okay, alpha is 0.5 and class is B. Okay, now as I have used label, so I have to write plt.legend, and finally I have to write plt.show. Okay, now if I execute, now see, this orange is my class 1, class A, all the orange bins is my class A, and for green is my class B. Okay, these bins are class B, right? So this is how you can place multiple histogram in your chart. Okay, and now let's see how we can write our histogram code using object oriented approach. Okay, that is new approach, object oriented approach. Okay, now let me take the same example. Okay, this is my old approach. Okay, this is my old approach. Now I am using the same example using new approach. Okay, that is object oriented approach. Now for that I have to write figure comma access plt dot subplots, and instead of writing plt.hist, I have to just mention access. Okay, ax.hist. Okay, and rest are same. Now if I execute, now see, I'm getting same result. Okay, I'm getting this same result. Whatever I'm getting using this old method, the same result I'm getting using my new method, that is object oriented method. Okay, I'm getting same output, right? So I hope you understand what is histogram and when we need to use histogram and how to create histogram and how to customize our histogram. That means all the fields. Okay. So this is my module 8. And here I'm creating my file as pie chart. Okay, pie chart.ipynb. Now let me select my kernel. Okay, so basically pie chart is a circular graph divided into slice. Okay, always remember pie chart is a circular graph divided into slice where each slice represent the portion of the total data. Okay, so basically whenever we need to show our proportion of the data, whenever we need to show percentage of our data, whenever we need to compare all the parts of our whole data, and most importantly when our category in our data set, whenever our category is very small, then we need to use pie chart. Okay, so to use pie chart, first of all I have to import my Matplotlib. Okay, import matplotlib.pplot as plt. Okay, now I'm creating a small data. Okay, I'm creating a small data. This is my data and I am putting value as 40, 30, 20 and 10. Okay, now in order to create our pie chart, we have to use plt.py. Okay, plt.py, and here I have to pass my data. Okay, then plt.show. Now if I execute, now see, I told you pie chart is basically a circular graph. Okay, circular graph divided into slices. So these are all slices. So I have four data, that is 40, 30, 20, 10. I have 4 data. So my entire pie chart gets splitted into 4 parts. Okay, the slice is 4 slice. Now if I want to add labels, okay, then I have to pass my labels. Suppose I want to give the label name of each slice as ABCD. Okay, ABCD, something like this. Then I have to pass my data. Okay, label data. So these my labels. Okay, I have to pass my list of labels. Suppose A, B, C, and D. Okay, now once I have passed my label, okay, then I have to pass a parameter, that is label. Okay, I have to pass this labels parameter, and here I have to pass this variable, that is labels. Okay, so automatically my label name, whatever I have given as a label name, this label name get assigned to each slice. Okay, now if I execute, now see, this slice assigned as A, this is B, this is C, this is D. Okay, so basically I'm customizing my pie chart. Okay, I'm customizing. Now this is my entire data. Now suppose I want to see the percentage of this data. Okay, this what is the percentage of this blue portion, what is the percentage of this orange portion, like this. Okay, so for that I have to pass another parameter that is called auto percentage, that is called auto PCT. Okay, auto PCT, that is called auto percentage, and here I have to pass a percentage format. Okay, percentage format. So percentage format is percentage 1.1 f, then 2 times percentage. This is the format of showing percentage. Okay, now if I execute, now see, this slice is 40%, this slice is 30%, this slice is 20%, this slice is 10%. Okay. Now automatically Matplotlib assign this color to each slice. Okay. Now suppose I want to customize these colors as well. Okay. I want to assign different color to each slice. So for that I have to mention my color list as well. Okay. I have to pass my list of color. Suppose first one is red, second one is blue, third one is green, and fourth one is orange. Okay. Now here I have to use one parameter that is called color. Okay. That is called colors. And here I have to pass my variable that is color. Now if I execute, now you'll see that this chart color got changed. Okay. Now see, my first one is red, second one is blue, third one is my green, and fourth one is my orange. Okay. So this is how you can customize your slides color. Okay. Now suppose you want to highlight any of the slice. Okay. Suppose you want to highlight your this red slice. Okay. Then again you have to pass one list of value. Okay. List of value that is called explode value. Okay. So explode, I just mention a variable explode, and here I just pass. Suppose I want to highlight this one only, red. Then I want to mention 0.1. That means this red slice will be pulled outside. Okay. So the value is 0.1, and I don't want to pull out any other slices. So I just pass 0, 0, 0. Okay. And I have to pass one parameter that is explode. Okay. And I have to pass this explode variable. That's it. Now if I execute, now see, this slice gets pulled outside. Okay. That means I am just highlighting this slice. Okay. Now in the same way, if I want to highlight this green slice as well. Okay. So that means I want to pull this slice as well. Okay. Then I can pass 0.1 value over here as well. Okay. Now if I execute, now see, this slice also get pulled outside. Okay. So this is how you can highlight your any slice by pulling this slice little bit outside. Okay. Now if you want to rotate your chart, then you have to use another parameter that is called start angle. Okay. Start angle. And here you can pass any degree. Suppose I want to rotate it as 90 degree. Okay. Now if I execute, now see, it gets rotated. My entire chart gets rotated at 90 degree. Okay. Now I want to add some shadow under each slice. Okay. So it will be more attractive and it will be more highlighted. Okay. So to add the shadow, we have to use another parameter that is shadow. Okay. Shadow, and you have to mention true. Now if I execute, now see, one shadow get assigned to each slice. Okay. So it's looking good, and it is more appropriate for highlighting our slice. Okay. So this is how we can create our pie chart on any of our data. Okay. And we can customize based on our requirement. Okay. But always remember, whenever we have less category in our data, then only we need to use this pie chart. Okay. And finally, we'll see how to use our new approach. Okay. That is object oriented approach. Okay. This is our old approach. Now see our object oriented approach. Okay. Object oriented approach. Okay. I am taking same example. Just here I have to pass figure AX, that means axis, PLT, dot subplots, and instead of PLT I have to write axis, okay, AX. And now if I execute, now see, I'm getting the same result. Okay, I'm getting the same result, but this is my new approach. Okay, that is called object oriented approach, right? So I hope you understand how to create pie chart and when we need to use our pie chart and how we can customize our pie chart based on our requirement. Okay. Next we have text and annotation. Okay, text and annotation. So for example, this is my graph. Okay, this is my graph. These are my points. Okay. Now, only visually representation of this graph is not appropriate. Okay. So basically, we need to make our graph as storytelling graph. Okay. Storytelling graph. Okay. That means whenever any user see this graph, he or she able to understand what this graph wants to tell. Okay. For example, we want to highlight our midpoint of this line. Okay. Suppose this point is our midpoint. Okay. Now we want to highlight this position. So we want to write a text mid position. Okay. Mid position. We want to write this text mid position. Okay. So in order to write this type of text, we have to use text, Matplotlib text. So we have to write like something like this: PLT text, and here I have to pass my x and y, and this x and y is the position of x axis and y axis. Okay, if this position is, suppose this is my x position of 8 and y position of 9, then we have to pass something 8 comma 9, and then I have to pass my text. So that means midpoint. Okay, now if I execute this code, then automatically one text will be printed over here. That means my graph wants to say that this is the middle point. Okay, so this is very much appealing to the user. Okay, so this is Matplotlib text. Okay, now you can customize your text based on your requirement. You can change font size. You can change any color of this text. Okay, but there is a limitation in this text. You cannot use any kind of arrow. Okay, you cannot use any kind of arrow, and you cannot highlight. You cannot mention any kind of clean highlighting. Okay, that means suppose I want to create one arrow over here. Okay, I want to create one arrow over here. So it will be more appealing. Okay, visually more appealing. So using text, I cannot create this graph, this arrow. Okay, and also if I want to put this text over here, okay, that means my highlighting position is this. Okay, my highlighting position is this, but I want to keep my text over here. In case of text, whatever my highlight position, my text will be appeared beside of that. But suppose I want my highlight position is this, but I want my text has to be here. Okay, has to be here, and at the same time I want to use this arrow. Then I cannot make it using text. Okay, I cannot make it using text. Then annotation comes into the picture. Okay, using annotation you can customize your text, you can customize your arrow, and you can customize as you want. Okay, so basically it will be more storytelling approach. Okay, more storytelling graph approach. So I hope now you have basic understanding about text and annotation. Now let me show you the practical. Now you'll get the more full clarity about how to use text and annotation in practical. Okay, so this is my module 9. Okay, so I'm creating my file text and anno. Okay, text and anno dot ipyn. Now I'm selecting my kernel. First of all, I'm just creating a simple plot. Okay. So for that, import matplotlib dot plot as plt. Now I'm getting 2 point x. X is my 1, 2, 3, 4. Okay. And y is my 10, 20, 30, and 40. Okay. Now I'm creating my plot. That is my line chart. Okay. So plt.plot. And here I'm passing my x and y. Okay. Now plt.show. Now if I execute, this is my simple line chart, simple plot. Okay. Now suppose I want to, this is my all point. Okay. Now I want to make a text. I want to put a text in the middle point. Okay. Middle point. Suppose I want to make a, I want to put my text at the position of 220. Okay. In x axis at 2 second position 2, and in y axis at 20th position. Okay. 220. So in this position I want to put a text. Then for that I have to write plt.text. Okay. plt.text. Now here I have to pass my x axis value. That means 2. And y axis value. That means 20. Okay. In this position 220. In this position I want to put my text. Okay. And now I have to write my text. Okay. Whatever text I am to keep in my chart. So I just write midpoint. Okay. Midpoint. Now if I execute, now see. In this position 220, in this position my midpoint text gets appear. Okay. Now you can customize your text. Okay. Suppose I want to use my font size. Okay. I want to use my font size, and I just give font size as 12. Okay. I want to make my text color as red. Okay. So for that I have to write color, and I have to pass red. Okay. And I want to make this text as bold. Okay. So for that I have to write font weight. Okay. Font weight as bold. Okay. Now if I execute, now see, my text gets bold, font size gets changed, and my color is red. Okay. So this is how you can customize your text. But the problem is, using text you cannot use any kind of arrow, and there is no clear highlighting. Okay. So in that case you have to use annotation. Okay. You have to use annotation. Now for this annotation. Okay. Let me write, this is my text. Okay. This is my text, and now it will be my annotation. Okay. So let me copy the same thing. Okay. Now instead of writing plt.text, we can write plt.annote. Okay. plt.annote. And here I have to pass, first I have to pass my text, whatever text I am to keep. Suppose midpoint. Okay. Now here I have to pass my text position. Okay. Here as I have passed 220, that means as at 220 position I am printing my text. Now I have to pass my position. Okay. So for that I have to write xy. I have to write xy equal to, and now within this parenthesis I have to pass my x value and y value. Okay. Now if I execute, now see, I'm getting same output. But it is using annotation. Okay. Now you can customize your text, right? Now if I make it 440 and execute, now see, it goes over here. Okay. And I can mention this one as pixels. Okay. Pixels. This is the highest point. Okay. So I can write as pixels. Now suppose I want to use arrow over here. Okay. I want to use arrow over here. For that I have to pass one parameter, that is arrow crops. Okay. Arrow crops. And here I have to pass dict. Now I have to put my parenthesis, and now here I have to pass my face color. Okay. Whatever color I am to give to my arrow. Okay. So that is face color. And suppose I am to give black. Okay. Now this is my highlighting position. Okay. 440. This is my highlighting position. But I want my text should be appear in different place. Okay. Now see here, if I execute this code, then automatically at this point, this is my highlighting point. So automatically the text will be appears in this highlighting position. This is by default. Okay. But suppose I want my text should be appear in different place. Okay. Then I have to pass another parameter, that is called xy text. Okay. xy text. And here I have to pass my another x and y axis value. Okay. So suppose I want to show my text at 350 position. Okay. 350 position. That means this is my text that I want to print. Okay. In my chart, this is my highlighting position, which point I want to highlight. Okay. This is the text position. In this point I want to print, I want to appear my text. Okay. And this is my arrow. Okay. Now if I execute, now see, this is my highlighting position, that is 440. Okay. This is my highlighting position 440. So arrow is basically highlighting this position, that is 440. Okay. Whenever I use arrow crops, automatically my arrow will highlighting, or arrow will point to my highlighting position. Okay. Automatically my arrow will point to my highlighting position. So highlighting position is my 440. Okay. Now this text, as I used xy text, so instead of printing my text over here, over beside this highlighting position, it automatically shifted to this position, that is 350. Okay. This position is 350. Okay. So automatically my text is getting appeared in this position 350. Right. Now what you can do, you can customize your arrow as well. Okay. Simply you have passed the face color of the arrow, that is black. Now you can customize your arrow as well. Okay. So what we can do, instead of writing face color, we can write arrow style. Okay. We can give a arrow style. Okay. And here I just pass dash greater than. Okay. This is my arrow style. Okay. And I can give a color. To my arrow. Suppose red. Okay. Now if I execute, now see, my arrow style gets changed and the color is red. Okay. Now if you want to change the direction, okay, this arrow is direction is this side. Now if you want to change the direction, just write something like this, less than dash. Okay. Now if you execute, now see, the direction gets changed. Okay. So this is how you can customize. Your arrow. Okay. Now I'm creating another example where I want to show you how to highlight highest position and lowest position. Okay, how we can highlight this type of position. Okay, highest position, lowest position, something like this. Okay, so first of all, I'm importing my Matplotlib dot pplot as plt. Now I'm creating one variable, that is sales. Basically, I am to graph my sales data. Okay, I am to graph my sales data, and I want to highlight my highest sale data and lowest sale data. Okay, so this is my sales data: 100, 150, 120, 200. Okay, and this is my months data. Okay, suppose this is Jan, this is Feb, March, and April. Okay, now I just plot my data, plt.plot. In X, I just pass my month, and in Y, I just pass my sales. Okay, and to highlight my point, I just use marker. Okay, marker. Now, if I write plt.show, now see, this is my sale data. Okay, and these four are my sales point. Okay, this is the first one, this is the second one, third one, and fourth one. So this is my sale data. Okay, I just marked my each point. Okay, now my aim is to highlight this highest position and this lowest position. Okay, to highlight this highest position and lowest position, I want to put some text, I want to highlight this area, I want to put arrow over here. So basically, I want to make my graph more storytelling. Okay, so whenever any user see my graph, he or she will be able to understand what my graph wants to say. Okay, so I have to, first of all, I have to find out my maximum value and minimum value. Okay, so for maximum value, we can use max of sales, right? And we have to find out maximum index, that is index position. Okay, maximum index. So that is sales dot index, and here I have to pass my maximum value. Okay, in the same way, I have to find out my minimum value. Okay, minimum value, and this is my minimum index, this is my minimum value. Okay, so basically I just find out my maximum value and minimum value. Now I need to plot my maximum value and minimum value to my chart. Okay, so for that I have to use plt.annotate. Okay, here I want, first of all, I want to pass my text, that is highest sale. Okay, this is my text. What is my highlight position, that is XY, and here I have to pass my X position and Y position, that means X axis and Y axis. So here I have to pass my months of max index. Okay, this is my X, and my Y is max value. Okay, so this XY is my highlighting position. So here I have to pass my X axis and Y axis value. So my X axis value is months of max index, and Y is max value. Okay, now I want to I want to put my text in some location, and we can mention our xy text. That means where I want to keep my text. Okay, at which point. Okay, now here also I need to pass my x-axis and y-axis value. Now here also I have to mention months of max index. Okay, months of max index. Okay, and my x is max value plus 30. Okay, I'm just shifting my text. Okay, I just whatever my max value plus 30, I just shifting my text. Okay, if I don't pass this 30, then my xy value and x text value will be same. That means my highlighting value and text position value will be same, but I want to shift my text little bit upside. Okay, that is why I just mentioned plus 30. Okay, so this is my text position. Now I can pass my arrow. Okay, arrow props. Now I have to write dit, and here I have to pass my arrow style. Okay, arrow style, and my arrow style is dash greater than, and I can pass a color, suppose green. Okay, so this is my highest cell position. Okay, so this is my highest cell position. Now in the same way I have to create my lowest cell position. Okay, so this is my lowest cell. Okay, mean index, mean value, is also mean index, mean value. Here I just mention minus 40. Okay, I'm just shifting my text minus 40, right? And color red. Okay, also I need let me add some labels. Okay, let me add some labels. plt dot title monthly sales analysis. Okay, I just add x label, that means month. Okay, and plt dot y label, that is sales. Okay, now if I execute, now see, lowest, just a minute, max of sales, mean. Okay, sorry, this should be mean of sales. Okay, now if I execute, now see, this is my highest point, so it has been highlighted. This is my arrow, and my text position is this highest cell, and this is my lowest position, and my arrow is color is red, and this is my text position. Okay, this is my highlighting position, this one. Okay, that is xy. Okay, and this is my text position, that means this xy text. Okay, I just mention minus 40 and here plus 30, that is why it is shifted little bit over there. Okay, so these are, we can highlight our chart. Okay, we can highlight any point, based on our requirement. Okay, so basically we are making our chart more storytelling for the user. Okay, so I believe you understand what is text and what is annotation, and how to use them in our chart for making our chart more storytelling. Okay, so till now we have learned the most commonly used chart, right? Like line chart, bar chart, scatter plot, histogram, pie chart, subplots, annotation, everything. Okay. Now we'll run some advanced plot types that mostly analysts, statisticians, and researchers often use. Okay. Some advanced type of plot. So this is my module 10, advanced plot. Okay, advanced plot dot ipynb. Now I'm selecting my kernel. So first one is box plot. Okay, box plot. So basically box plot shows the minimum value of our data, first quartile, median value of our data, third quartile, maximum value, and outlier from our data. Okay. So let's see how we can create our box plot. First of all, I have to import my Matplotlib dot pplot as plt. Now I'm creating one data. Okay, 10, 20, 30, 40, 50, and 100. Now, in order to create my box plot, I have to write plt dot box plot. Okay, and here I have to pass my data. Now I just add some title. Box plot example. Okay, and here plot plt dot show. Okay, now if I execute, now see, this is my box plot. Okay, this first line, this is my minimum value. Okay, this is my minimum value from this entire data. This is my minimum value. Okay, this line is my first quartile of my data. This is my first quartile, that is Q1. Okay, this orange line is my median value of my data. Okay, this line is my third quartile. Okay, third quartile, that is Q3, third quartile of my data, and this is my maximum value of my data, and this is my outlier. Okay, this is my outlier. Outlier means the data which is lies far beyond my race data. Okay, now see, here I have my 10, 20, 30, 40, 50. Okay, up to 50, all these data are almost lies near to each other. Okay, so this data is coming to this box. Okay, but 100 is far beyond this data. Okay, that is why 100 is coming over here as a round shape. That is called outlier. Outlier is basically which data is completely far beyond my race data. Okay, so to from my data, to find out the minimum value, maximum value, median, first quartile, second quartile, and what are the outlier in my data, to find out all these things, we need to use box plot. Okay, now I give you another example of multi box plot. Okay, multi box plot. Now this is my, suppose, data 1, 10, 20, 30, 40. This should be Python. And my data 2 is 20, 30, 40, and 50. I have to write plt dot box plot, and I have multiple data, so I have to pass all my data in a list format. Okay, so I have to pass my data 1, comma, data 2. Right, now plt dot show. Now if I execute, now see, these multiple box plot. In this way, you can place any number of box plot in your chart. Okay, this is my data 1, this is my data 2. For data 1, this is my minimum value, this is Q1, this is median, this is Q3, and this is my maximum value. And there is no outlier in this data. There is no outlier, so there is no outlier shown over here. In the same way, this is my data 2. This is a mean value Q1. This is median. This is Q3, and this is maximum value. Okay. So this is the box plot. Next, we have violent plot. Okay. Violent plot. So basically, violent plot is basically box plot plus distribution shape. Okay. Distribution shape. Okay. It shows basically median, spread, density of the shape, everything. Okay. So for example, Matplotlib dot pplot as plt. Now I want to create 100 random numbers. Okay. So for that I have to import NumPy. Okay. Import NumPy as np. Now my data is np.random normal. That means I want to create normal distribution. Okay, I want to create some data of normal distribution. Okay, where my location is 0. That means the mean of the data. Okay, the mean of the data, and scale is 1. That means the standard deviation of my data is 1. Okay, and here I have to pass my size. So basically, in order to create my normal distribution shape, I have to pass location, scale, and size. Okay. So my location means the mean value of my distribution. My data, mean value of my data. This is my standard deviation of my data, and this is the size. How many number I want. Okay. So I want to create 100 random normal distribution number. Okay. So this is my data. Now if I write plt dot violent plot. Okay. And I have to pass my data. Now plt dot show. Now see, this is my violent plot. Okay. In this area, all my data, all my 100 number of data is aligned in this shape. Okay, in this shaded area. Okay. Basically, you use this violent plot when you need full distribution visibility. Okay, and sometime when you comparing multiple distribution, then you have to use violent plot. Okay. Next, we have area plot. Okay, area plot. Basically, area plot shows field area below a line. Okay. Now, for example, I'm getting 2 point x 1, 2, 3, 4. Okay, and y 10, 20, 15, 30. Okay. Now, in order to create my area plot, I have to write plt dot fill between. Okay, fill between, and here I have to pass my x and y. Now plt dot show. Now if I execute, now see, this is my area plot. Basically, this is my point, first point, second point, third point, and fourth point. So basically, this one line. Okay, this is one line, and the shaded area below this line is called area plot. Okay, these 4 are my point. These 4, this one, this one, this one, and this one. These 4 are my point. Okay, so if you connect all these points, so it become a line, and the shaded area and the filled area below this line is called area plot. Okay, and the use cases of this area plot, when you need to find out some revenue growth, traffic trend, cumulative trend. Okay, this type of analysis you have to use this area plot. Okay, next we have stack plot. Okay, stack plot. So basically stack plot shows contribution of multiple categories over time. Okay, it shows contribution of multiple categories over time. So for example, I'm creating x 1, 2, 3, 4. Okay, and for category, suppose I am creating one product A. Okay, product A 10, 20, 30, 40, and I have another category, that is product B. Okay, and the value are 5, 10, 15, 20. Now in order to create stack plot, I have to write plt dot stack plot. Here I have to pass my x, then I have to pass my product A and product B. Okay, and for legend I can use one label. Okay, for creating legend I have to use labels, and here I have to pass A and B. Okay, then plt dot legend, and here plt dot show. Okay, now if you execute, now see, this blue is my A, this blue is my B. Okay, so basically this x axis, okay, these are my time. Okay, this x axis is my time, and this is my product of A and this product of B. Okay, so basically it is showing the contribution of the category over time. Okay, and it is stacking together, so it is called stack plot. Okay, so basically the use case of this stack plot, when you are performing any kind of analysis on market share trend, product contribution analysis, then you have to use this stack plot. Okay, next we have error bar plot. Okay, so basically error bar plot shows uncertainty or variation in data. Okay, for example, I'm creating x 1, 2, 3, 4, and another point y. Y is basically 10, 20, 30, 40, and my error point. Okay, my error 2, 3, 4, 2. Now plt dot error bar. Here I have to pass my x and y, and y error. Okay, y error equal to my error. Now if I show, now see, this is my error bar plot. So basically it shows uncertainty. Okay, these are uncertainty. Okay, so basically this bar basically used in scientific experiment. Okay, machine learning confidence interval. Okay, survey margin, this type of case we need to use error bar. Okay, to show some uncertainty in our graph, right? Next we have stem plot. So basically stem plot used for discrete signal. Okay, so dot plus I just mentioned it, basically dots, that means my points. Okay, my points plus vertical line. vertical line. That means all my points, this dot means all my points, okay, all my data points, and below this there is a vertical line. This is called stem plot, okay. Stem plot looks like this, okay, dot and below this vertical line. So if I create x equal to, let me copy this one. Now plt dot, in order to create my stem plot, I have to write plt dot stem, okay, plt dot stem, and here I have to pass my x and y. Now plt dot show. Now if I execute, now see, this 4 dot is my data point, okay, this 4 dot is my data point, and the vertical line, this vertical line of this dot, okay, this is called stem plot, okay, just dot and below this dot the vertical line, this is stem plot, okay. And the use case of stem plot is signal processing, frequency analysis, all these things, okay. Next we have step plot, okay. Step plot used when values changes in steps rather than smoothly, okay. If I give same example, 1 2 3 4 10 20, looking at 20, and this 30. Now you have to create step plot, I have to write plt dot step, and here I have to pass my x comma y. Now plt dot show. Now see, this is my step. This is my first point. Second one 220, somewhere around here. Third one is 320, somewhere around this one 320, and my fourth one is 430. That is 430 here, okay. So basically it is giving me value change in steps, okay, value change in steps. And the use cases of this step plot is inventory changes, pricing tiers, event tracking, all these things, okay. So I hope you understand these few advanced type of charts and how to create these charts and when we need to use this chart in our project, okay. So guys, that's a complete overview of Matplotlib from beginner to advanced concept, okay. So in this video I have shown you how to create different type of charts in Matplotlib with multiple examples, so you can understand where each chart is used in real world scenario, right. But learning visualization only becomes powerful when you practice it yourself, okay. So don't just stop here, take different dataset, experiment with different chart types, and practice as much as possible to build stronger clarity and confidence in Matplotlib, okay. Also, I have added the GitHub repository link in the video description box where you can access all the code files and you use them for your own practice. If you found this video helpful, make sure you like the video, subscribe the channel, and share with someone who wants to learn Python data visualization. And let me know in the comment which Python library you want me to cover in the next video, okay. So thanks for watching. I will see you in the next video.